Uh, if you remember or recall how the babies learn from the environment, initially when the baby is born, they would like to recognize their parents, especially the mother, then father, and then siblings, and so on. So that is the first experience of the babies in learning of this real-time world. So in this learning, normally they recognize the parents or their family members with the help of vision. They see, they recognize, and after this learning, the next step is learning through audio. If baby's mother talking, she would like to recognize with the help of audio. So first is vision, then sound. So sound is a very important aspect in the human life, and these two features also very important in machine learning. Machine learning basically the learning of any given machine. It may be robotics, it may be computers, it may be anything, any machine which can learn. So when we talk about the learning, the different dimensions of machine learning could be classified as different types of learning. It may be supervised, unsupervised, or reinforced. For example, in the early childhood, the babies will learn with the mother's supervision. They do something and mother will guide them, supervise them, and they will learn the correct things. Also, after a certain age, the babies will try to become independent and they learn with unsupervised learning. For example, if you give the building blocks to babies, they will try to make their own items with their own intelligence, and that is unsupervised learning. No guidance required. They try to be independent, and that is unsupervised learning. So they prepare some innovative things, strange things, which we could not teach them. So in unsupervised learning, sometimes you can find very innovative ideas, innovative things, out of box thinking may be there. And lastly, when the children goes into schools and colleges, then there will be reinforced learning. Reinforced learning means we are forcing certain things to learn. So the teachers will try to teach something with the help of award punishment scheme, and that is reinforced learning. So we are reinforcing certain things to learn. So that is about the different types of learning normally occur in the human life as well as in the machine learning. Then the next step is dimensions of a learning system. In this, the feedback is very, very important. Different types of feedbacks, representation of knowledge, usage of knowledge. So these are the different dimensions of learning systems. When we talk about the supervised machine learning, different algorithms come across like decision tree, neural network, support vector machines, Bayesian network learning, nearest neighbor models, and so on. So it's unlimited learning algorithms. Some of them may come across the deep learning and so on. So we will discuss in brief about uh, these learning algorithms. Mainly we focus in today's talk about neural network and its learning algorithm. So when we talk about the machine learning, three main features are there, like images, image processing, image recognition, image morphing, and so on. So how do we recognize the image? For that, we identify different features of it, feature identification. And that is one of the very important component of machine learning. Similarly, in audio, when we speak something through microphone, the audio signals will go into the computer, and then we identify the audio features, different types of features. I'm not going into the details about what features you may consider, but we identify the audio features and then we identify the speaker. For example, somebody will come to your house in the morning period about between 7 and 8, and pushing the bell or calling you. Automatically you can recognize that who is at your door. So with the help of audio, you can identify the person who is calling you, or so identification with the help of audio as well as the images. Sometimes images may not be there. With the help of audio also you can recognize. Sometimes audio is missing, only the images are there, you can recognize them. Similarly, in the computers, especially when you talk about the Google intelligence, artificial intelligence in the Google softwares, images, audio, and text is also there. So the text, when you speak something, it will convert into text. If the text is there, it will be converted into audio. And nowadays you can find many audio books. So text is automatically converted into audio, and no need to you to read that text. Automatically the computer will read and tell you what is written inside. So these are the innovations which changed the dimensions of artificial intelligence. If you talk about the human beings, the question comes, how does human work? Or who does control human behavior? So you give certain inputs to the human and you get certain outputs from the human in the form of human behavior. So what are those inputs and what are those outputs and what is in between them? So the inputs we can normally receive from different sensory organs. As you can see here, you can see something with your eyes, that is vision input. You can hear something with your ear, that is audio input. Then you can touch certain things and you can get the inputs, touch sensation. You can test certain things with your tongue, and that's another input. Then the smell, your nose will give certain inputs to your brain. So these are the different inputs from the sensory organs. So different sensory organs will give different inputs. So senses environment is there, which receive the sensory inputs from sensory organs and give it to the brain. Now, what is inside the brain? Brain has certain knowledge, brain has certain understanding about it, brain has reasoning power, learning power, and so on. So that's internal processes which are going on into the brain. So it's a mechanical thing. You have different types of knowledges in different parts of the brain. Audio knowledge in one part of the brain, video or vision knowledge in other part of the brain, and so on. So different parts of the brain contains different types of knowledges. So you can learn different things, and then you can reason it, you can understand it, and you can exhibit your behavior. The output will come out in the form of behavior. How the human will exhibits his behavior. So that is the final output. But the second question, as mentioned, who does control this human behavior? So if you talk about the controlling part, the brain is basically controlling everything. So brain is the heart of this process and controls everything. If you talk about the human brain, a human brain is composed of neurons, and these neurons work at a very slow speed in comparison with the computers. Computers are very fast, but then also the humans are more efficient than computers due to massive parallel processing in the brain. Moreover, not only humans, but even animals can process visual information better than fastest computer. Not only the visual information, but smell information, audio information, and so on, they can process better than your fastest computer, supercomputers. For example, the dogs, especially the searching dogs, dogs helping to the police or the investigation agencies, their audio capability, their smell, the capability to smell certain things much better than any other artificial sensor. They can grasp that smell and then identify the person based on the smell. So that is the fastest processing. They have machine learning, or you can say the intelligence in that particular sensory organ. But unfortunately, the understanding of human brain is not complete. Right now, the era in which we are living here, we are not completely understood how the brain functions. Human brain functioning is still incomplete because the human brain is most complicated computer in the human body, and it can not only process a single information or multiple informations, but it can process the information which is not existing, which you are not giving to the brain. For example, in the deep dreams, when your sensory organs are closed or not working at all, for example, your eyes are closed, your ears are closed, you are not able to listen outside sound in the deep sleeps, but then also the brain is functioning based on certain informations which they are getting from some other higher level of sensory organs. So the human brain is most complicated part of the human body, and we understood only the superficial functioning of the human brain. We are not still able to understand how the brain completely functions. Our objective here is to develop human-like autonomous machine which has intelligence, perception of speech and vision, inference, reasoning, decision-making, movement capabilities, and cognition. So, can we include all these features into the machine? So most of the features are implemented, but still the cognition is the most difficult feature to include into the autonomous machine. Recently, a couple of PhDs completed with me, where we have developed the cognition machines for teaching, cognition machines for helping the doctors in medical sciences. And we also developed the autonomous moving machine that we call as SIM, a smart moving intelligent machine, which can smartly manage their movements, and they can go anywhere. And this is very useful, especially for the defense purposes, to identify the underground mines, to avoid unnecessarily explosions and death of casualties of our defense people. These autonomous machines can destroy bombs and so on. So numerous applications in the defense, and we got a project also in this regards to develop autonomous cognition machine which can identify the dangerous objects and then give that information to the central computer and then process it and then try to destroy that. So basically, when we talk about the intelligence into the machines, the biological neuron is the most important thing in the human brain, and we try to mimic the similar neuron into the machine. So we are trying to develop the artificial brain into the machine. But as I told you, it is not only difficult, but it is impossible to develop the human brain, replica of the human brain into the machine, because human brain has multiple functioning. It is not only a single dimension, but multiple dimensions of the brain, and you cannot replicate all the dimensions into the machine or the artificial brain. A typical neuron has three major regions as shown here: cell body, axon, and dendrites. Dendrites receive information, axons give information to the other neurons, and so on. So that is basically the biological neuron. I'm not wasting the time on this. Then we have artificial neuron developed, where we are trying to replicate the biological neuron in the form of artificial neuron or silicon neuron on chips. So you have the different inputs with certain weights, then they will be summed up. And if this weighted sum is more than certain threshold value, you can get the output. Then we combine these neurons and make network, which we call as artificial neural network, ANN, consisting of many simple elements called neurons, and develop ANN in two phases. The first is training phase, other is testing phase. So in the training phase, the network will memorize the pattern of learning data, and in the testing phase, the performance of network is to be checked with the help of given testing data. But in this training phase, the problem comes if you have quite complex data are the problem. So most of the time your network will stuck into the local minima and could not reach to the global minima or reduce the error to the tolerable values. So that problem always occur in neural network while supervised learning or backprop learning. Now, here you can see an example of supervised learning from tech data. When the small babies learn to identify the coffee mug, you have to show different designs and different types of coffee mugs to the child, and then you can show the coffee mug and the child can easily recognize. So in testing, you show it, what is this? And the baby will recognize this coffee mug and tell you the answer. But what will happen if you show this type of mug? What's about this? This is a coffee mug or a saucer containing biscuits with a cup or something else. Or if the coffee mug is containing some scenery on it or some photograph on it, like Sushant photograph here, so can the baby will recognize it's a coffee mug? Can your machine can recognize this coffee mug? So to answer this question, it is necessary that what are the datas you have included in your training. If you included these type of patterns or the features into your training data, then your machine can identify that yes, this is also a coffee mug, although it is containing some scenery or photograph or some picture or something. So for that, now we need deep learning. So in deep learning, the object models are there. Then from these objects or object models, we identify different parts of the object. And then in those parts, we identify the edges. And then in that edges, we identify the pixels. So these are the different layers in deep learning. So we start with the grassroots level, and then we go up from bottom to top approach and identify different objects. So that is basically the deep learning. In deep learning, we are going into the depth of the objects. We disintegrate the object into different parts, different edges, different pixels, and so on. And then we identify the objects. So in this case, we come to a conclusion that if you increase the amount of data, then learning will be better, performance will be better, as I have seen in case of coffee mug. If you increase the number of different types of coffee mugs, then it will be easy to identify the given coffee mug. So basically we are increasing the amount of data for getting better performance. But in the older algorithms, there will be a saturation comes when the amount of data increases, the performance will not increase with the same rate, but there is a saturation. A near point will come. After that, the performance will not increase. But if you talk about the deep learning, the performance will continuously learn, and the near point will come quite after as compared to the older algorithms. So deep learning is better than the older algorithms. Now, if you talk about the performance of networks, neural networks, it is basically depending on the problem complexity of learning algorithm, and network complexity. So there are three things here which are affecting the performance of neural network or machine learning. Number one is the problem in your hand. So if your problem is quite complex, then the performance of network gets affected. Sometimes it is not able to understand the problem and give you the correct solution. Then you have a learning algorithms. Number of learning algorithms are there to train artificial neural network, and every algorithm has different complexities. So what complexity you can cope up and what learning algorithm you can choose, that will affect the performance of neural network. And lastly, the complexity of the neural network which you are going to consider. How many neurons are there, how many layers are there, and so on. So if you talk about the problem complexity, the number of training data and their accuracy, what accurate data you have, because in our Indian context, accuracy is very, very important thing. For example, if you are talking about the load forecasting problem, the data acquired may be not so accurate. For example, if you're talking about the load at any substation, normally what happens in the substations, the records are maintained by the attendant there. Whole night, they are not able to write down the exact load on the record book. In the morning, they just fill up the entries randomly. So if you talk about the accuracy, the data accuracy is very important. And if you give incorrect, inaccurate data, the training gets affected and your network performance will be drastically different. So it's very important, the accuracy of data, and then number of data. How many examples, how many data you are going to consider. For example, in case of coffee mug, how many types of coffee mug you have considered into the training. Then the next thing is the sequence of presentation of data. How you are going to present the training data to the network, that's also very important. For example, in the nursery class, when the teacher tell the student to write English alphabets, A, B, C, D, and so on, most of the time the child gets confused in a small b and a small d, because the shape is same, only the direction of that b and d just opposite, just reversed. So most of the time the children get confused. So what can we do for that? In this case, there are 26 alphabets in English, so you can teach the alphabets not in the same sequence as given in 26 English alphabets. You can start from, say, Y, X, only two slanted lines make X. It will be very easy for children to remember it. It will be very easy to remember Y. You have a slanted lines there, and you can easily make Y. Or you can easily remember P, Q, and so on, right? So what sequence you can present your data for training the network, that's very important. Sometimes you have to repeat the data. So what is the number of repetition required? For example, the student commit mistakes in writing B and B and D. So the teacher may tell them to write same alphabet maybe 10 times or 20 times or even higher. So that is the repetition, so that it can be remembered by the student. Same thing we can do for the machines to learn. We can present the same data n number of times. The repetition will be there so that it will learn how we can write B and D, or 3 and 6 in Hindi. If you write 3, you write 6, they are just opposite, right? I'm giving you a very simple example. When a small kid learn the whole process, learn how to write B and accurately write down B after learning. But when teacher told him to write down B, unfortunately, the student picked up the pen in the left hand and write B, but now it becomes D because the hands are different. It's rather picking pen into right hand, the student picked up the pen into left hand, and the process is changed. Algorithm is same, no change in the algorithm, but end result is wrong. So that's very important, how we are going to present the data and what are the different features which one has to, or what is the methodology which has to follow in inferencing the conclusion. So that's very important in learning. So problem complexity is very, very important part in your machine learning. Then types of functional mapping. For example, you can map the data input versus output, or you can check the change in input and the output, or you can take the input and change in output, or you can take change in input and change in output. So different types of functional mappings could be considered, and that will give different types of accuracies in the output results. I have tried all these functions and published a couple of papers in these. Then you can normalize the data. For example, if you are working with temperature, pressure, and so on, so your atmospheric pressure is there, your temperature may be 50 degree or 40 degrees Celsius or 30 degrees Celsius. So one variable is having range of tens or hundreds, other is having range of say 0 to 10 or 0 to 1. So you have to normalize so that equal weightage will be given to the data. So normalization is very, very important. Now you can normalize the data in the range plus minus 1 or plus minus 0.9 or 0 to 1 or 0.1 to 0.9 and so on. So different types of normalization ranges may be considered, and that will also affect the training performance of the machine. Then most of the time, accuracy of data is important, but sometimes we have to include certain noise in it so that the generalization capability will be there. Intentionally, we put certain noise into the training data. We are not giving the exact data, but some noise intentionally included in them so that your machine learning have generalization capability in it. Then nonlinearity is involved that will also affect the complexity of the problem. Sometimes the delays in the information also affect the problem complexity. So these are the different things which could affect the problem complexity. Then learning complexity, learning algorithm complexities, like in neural networks, the weight initialization is there. Most of the time we take random weights in neural networks. But the random weights requires long training time. If you take the optimized weights using generalized genetic algorithms, then the training time can be reduced. Selection of error. Normally we take the error as the difference between the desired and the actual output, or we take the square of error as error function. But if you take logarithmic error or cubic error, e raised to power 3, e raised to power 4, or some other error functions, how that error function will affect your learning capabilities. So that can also be studied. Then you can calculate the error based on the presentation of your data. You can present the data in batch mode, or you can present the data in pattern mode, individual data, and then calculate error, or cumulative error may be considered. Then initialization of training parameters. Whenever we talk about the learning, machine learning, there are certain parameters like the learning rate, how fast your machine will learn. What is the momentum factor there, and so on. So there are different training parameters which will also affect the complexity of learning algorithm. Lastly, the network complexity. When we talk about the network complexity, neuron structures, normally we consider the summation type neurons in which all the weighted inputs will be summed up and compared with the threshold value. to give output. But it is not necessary. This question I asked in 1991 to a neurologist, to a doctor, that how the neuron works in the human brain. It is exactly the summation there of the inputs or something else. So he said it is not exactly summation, but we cannot say what is happening inside the biological neuron inside the human brain. But it is certain there is not exactly the summation. It may be product, it may be something else. And that answer motivated me to work in this area to develop a new neuron. And then we developed a new neuron, which we'll discuss in a couple of minutes, that how the neuron structure can affect the network complexity and how you can reduce this complexity and develop a very good generalized network. Then these neurons are kept into different layers. So how many layers in the network, that will also affect the network complexity. If more number of layers, more complex network will be there, and it can tackle nonlinear problems, complex problems, and give you better output. But is there any formula to identify or calculate the number of layers or number of neurons in each layer? Right now, there is nothing, because we don't know the functioning of the human brain. And that's why about the artificial brain, we cannot exactly optimize that how many layers will give you the best results or how many neurons will give you the best result. It is problem dependent. For different types of problem, different types of structures of the network will give better results. Then number and type of interconnections. All these neurons are interconnected together. There is a massive network. So how many number of connections are there? How these neurons are connected? What are the different types of it? The connection may be deterministic, or it may be stochastic or random connections, and so on. So this will also affect the network complexity. So to keep these things into mind, we change the neuron structure, the neural network we have changed. We consider all summation neurons in the beginning, where the inputs are given to the network and output is taken from that, where you have input layer, which is distribution layer. Then you have hidden layers, where the processing is taking place, and finally the output layer, where the output is to be taken. Then we change the neurons from summation neurons to product neurons. So all the inputs not only summed up, but they are multiplied together to give the output. So a product neuron is developed and we got some outputs. Then we have taken the combination of summation neuron at the hidden layer and the product neuron at the output layer. And then we change them. The product neuron at the hidden layer and summation neuron at the output layer. And then we compared these different models. And we got very interesting results. And these are the results I got in way back about 20 years before. And this is for modeling and simulation of induction motor characteristic, starting characteristic, which is quite nonlinear in nature. So we used summation network, we used product network, we used combination. And you can see the training time required in terms of iterations, training epochs. So summation neuron required 1,150, product neuron 4,090, then the combination 50-50. If you compare the performance of these networks in terms of their root mean square error, you can find the minimum error obtained at the third model, that is 0.01661. That is the best one for training as well as the testing. The minimum error and the maximum error also less in this model. So you can see the combination is giving better results as compared to completely summation network or completely product network. The combination network giving better results. And that motivated us to work in these directions. So we developed the generalized network. In conventional networks, there are lots of limitations and drawbacks, as mentioned here. Large training time will be there, complex network structure. And to overcome these drawbacks, it is proposed to develop a generalized neuron having more power, more flexibility, and improved level of accuracy by modifying the conventional neuron architecture. So this is a generalized neuron structure where both functions are there, summation as well as the product, in the same neuron, and they are passing through different thresholding functions, sigmoidal function and the Gaussian function, and then the output is summed up. So that is we call as generalized neuron or higher order neuron. Many researchers call this as higher order neuron. Now we tested this neuron for different benchmarking problems like XOR problem, 4-bit parity problem, make a glass time series problem, and so on. So we have considered many benchmark problems and identify this accuracy of generalized neural network. Then we tested it. Once the benchmarking is over, we come to the real-time application of generalized neural network in power system applications. So we use this generalized neural network for machines modeling. We model the DC machine characteristics, induction motor characteristics, synchronous machine characteristics, and so on. We also used the generalized neural model for solar power forecasting, planning, controls, and so on. We have used this generalized neural network model for power system stabilizers. And we published many IEEE transaction papers in power system stabilizers. And that is my experimental work, which I did during my postdoctoral work in Canada in Power Systems Research Lab, University of Calgary, Canada. So first of all, as I told you, the modeling and simulation problem of induction motor characteristic, the starting characteristic, and we compared the simple neural network with the generalized neural network model, and the results are shown here. Similarly, synchronous machine characteristics, torque angle characteristics, and we compare the results. And you can see the generalized neural model very close to the actual characteristic. Then we used solar power forecasting, planning, and control with this generalized neural network applications. So the flow of work in this solar power forecasting, the planning and control at the top, and at the bottom we have IoTs or sensors, and these sensors are giving data, and the data are coming to the central computer where pre-processing of data is done, and then soft computing or neural network is used for forecasting. Once you have the forecasted output, then you can plan which devices you can switch on or switch off. So the controlling of these devices can be done based on their urgencies or the availability of power. So the methodology was like this. We have the sun, which is giving this solar power to our PV panels. These data come to our computer, and these solar PV panels are solar PV panels may be static or maybe rotating. We have both type of panels here. and both type of data coming to our computer. And then we are recording the data at different timings, 5 minutes, 10 minutes, 15 minutes. Even we reduce the time to 30 seconds. And we have seen the effect of ramp rate about this data. So we collected the data, and while collecting the data, we have taken the weather parameters, we have taken the monitoring the observations. The weather parameters may be temperature, wind velocity, clouds, humidity, pressure, and so on, solar irradiations. And these data are used for forecasting. We have also taken here the effect of range, effect of noise, effect of mapping, and cloud effects. Then we have used the generalized neural network for this, and we have considered different forecasting timings using different error functions, and then load planning and load controlling is there. So in the solar power forecasting, we have considered the site and data descriptions as follows. The PV system we have taken as 2.25 kilowatt, 1.5 kilowatt as static, and 0.75 kilowatt as rotating. The number of data for 12 hours. Time horizon we have considered for data is 30 seconds, 1 minute, 10 minutes, 15 minutes, and so on. And the forecasting is done for 1 minute ahead, or 10 minutes ahead, or 15 minutes ahead. The location is Faculty of Engineering, DEI, Dehradun. So these are the real-time data acquired for solar power for 24 hours and for different days, for 15 days. And these are the sun tracking system with rotating solar panel, designed and developed indigenously at the institute. So you can see here, there are two static panels of combination of 3 panels here and 3 panels here. They are static, which is 1.5 kilowatt, and this is 0.75 kilowatt as rotating system on a single pillar. So it is rotating. As you can see, the panel is changing its direction based on the sun. This rotation system, algorithm, and hardware is developed in the faculty itself. And these are the recorded data. And you can see here the difference in the solar power with rotating and static panels. So static panels, the power is always less than the rotating panels, because rotating panels always track the sun and generate optimal power. And these are the data collected at 30 seconds interval. And this is for 24 hours. So you can see here the smoothness of these graphs. The fluctuations are less. But if you record the data for 1 minute, the fluctuation will increase. If you record the same data for 10 minutes, the fluctuations even more. And for 15 minutes, you can see the drastic difference between them. So this is the screenshot of data acquisition system software developed by the students. And we are recording the voltage, current, power, time at different temperatures of the day. And you can select the time interval here, 15 minutes, 10 minutes, 1 minute, 30 seconds, and so on. And the data will be coming from COM1. And you can plot these data also in the screen. So these data which we acquired, given to the flexible neural network, where you have different generalized neurons at different layers. So these generalized neurons are connected together, and it is used for forecasting purpose. Now here, in forecasting of neural network for solar power, we have used the generalized neuron here. Input and output is given to find out the output. This output compared with the desired output, and error is calculated, and this error will modify the weights of the network. So modification is done through genetic algorithm, and this genetic algorithm will be modified by fuzzy rules. So it's a combination of genetic algorithms, fuzzy systems, and neural networks, all three together used to get better performance in forecasting. The parameters participating in solar power forecasting: power, temperature, pressure, wind, humidity, and cloud percentage. For example, here, the clouds are moving and the sun rays coming to your panel. Now, if these clouds will come in between the sun and the panel, then your power will be affected. If the clouds are moving away from the sun direction, then your panels will not be affected. So we have to identify the cloud motion. And once you detect the cloud motion, you can predict better the solar power. So this is the flow. We acquired the images, process these images, then identify the cloud, and then we also calculate the cloud motion, and then forecasting is done with the given data. So these are the data which we captured for clouds, cloud detection using K-mean clustering. And then there are two different images, image A and B. We identify the motion of the cloud, a modified region of two cross correlation to achieve the best results. So you can see the clouds are moving in from left to right direction. Then we compared the results with simple neural network and generalized neural network, and you can see the comparison between them. This is the online forecasting. We have a system in our faculty here where we can forecast the data online, which is very, very difficult but this is the real-time application of generalized neural network and the machine learning, where you can forecast the data online, and then online you can plan, and then you can control the different loads. So forecasting is done for 15 minutes ahead, and then you can plan for 15 minutes operation of any device or the load. So that will give you the best results. For decision making, for planning, we have used the fuzzy logic, fuzzy decision-based home appliance management system for optimizing. For example, you can operate your washing machine in 15 minutes, wash your clothes, and if the power available there, you can switch on your washing machine, or you can switch on your microwave oven, or you can switch on your refrigerator, and so on. So you can prioritize the loads based on their requirements. So priority loads will be switched on first, and then you can switch on the auxiliary loads also if excess power is there. So fuzzy decision making energy system, energy management system is there. And this is the practical implementation. The two loads are there, prioritized load and non-prioritized loads, which will be switched on automatically with the help of this hardware, and depending on the forecasted output of the network. So first, solar power forecasting is done using two different algorithms, various factors affecting solar power forecasting as studied. It is found that the small interval give more accurate results, and 5% noise will give better generalization capability. Cloud motions and cloud percentage turned out to be important factor in accuracy. And this algorithm, I had mentioned as genetic algorithm, fuzzy system, and give better results. Then planning and control of appliances is depending on our forecasting, and fuzzy-based planning controlling is more effective as compared to the other decision-making systems. The last application is GN-based power system stabilizers, where again, we have developed the power system stabilizer using generalized neural network, and it is implemented on the real-time machine controls for stabilizing the voltage. So you have a conventional power system stabilizers. The problem of conventional power system stabilizers, it is designed and developed based on the linear models, but all real-time power systems are nonlinear in nature. So the performance of conventional power system stabilizer is not accurate, and therefore the neural network and fuzzy set approaches have been proposed for stabilizers here. So ANN has intelligence, online learning, adaptive system, and that's why it is used here. This is the comparison of neural network and generalized neural network for power system stabilizer. You can see a drastic difference in the complexity of the network, number of neurons. In generalized neural network, only one neuron is there. In ANN, you have 8 neurons or even more. The number of layers are also different. Number of interconnections are more in neural network, simple neural network, as compared to generalized one. So generalized network is less complex as compared to the artificial neural network, conventional networks. So we have used these networks for implementing on the 400 megawatt generator at Manitoba hydropower plant, and we have tested it, and that is one of the publication in IEEE transaction. So you can go there and you can see the application of generalized neural network. So I'm just showing you a couple of results here, but in this, we have the power system stabilizer at the bottom here, and this power system stabilizer is through generalized neural network. So in this, the online parameter identification of the system is done, and the control strategy, online control strategy is developed. So that is the beauty of this work, that we are not identifying the parameters offline, but we are identifying online parameters and then controlling the system online. And it's very interesting to see that how this online network will give good performance as compared to offline controls. So you can see here different types of results. This is a plant and identifier. So we have developed the identifier first, and then after that we have controlled online the plant. And you can see here the generalized neural network is controlling much faster as compared to conventional stabilizer. When three-phase fault is there, or at different loadings, at light load conditions, medium load conditions, and heavy load conditions, and so on. Then the physical model is developed and implemented on 400 megawatt reduced scale macro synchronous generator. And then this laboratory model is verified the performance of generalized neural network, and then we implemented it on the real-time 400 megawatt generator. So we compared the results here. You can see the experimental results of generalized neural network based adaptive power system. Adaptive means it is having online learning. It learn online and modify the behavior. So I can show you that also, how it is doing at different loadings, different faults, different operating conditions. When the voltage is changed, torque is changed, ground fault is there, or some other transmission lines are switch on and off, and so on. So it is taken into account all types of operating conditions and check the performance. Then we have compared the generalized neural network power system stabilizer with adaptive generalized neural network power system stabilizer. So adaptive stabilizer and conventional GNS stabilizer, there is a difference. You can see the same fault is repeated after one cycle, and you can see the performance in the second cycle is much better as compared to the first cycle. So here it is fluctuating, but here it is stabilizing very quickly, and that is adaptability. So system will adapt. If you commit the mistake first time, the problem may be there, but second time if similar mistake will be there, it will perform much better as compared to the first one, and that we have demonstrated experimentally here. So this is implemented with the help of Texas Instruments TMS 320 C31 digital signal processing toolbox and so on. And we compared that with DSP boards. And these are the data which experimentally we got. And the same system implemented on multi-machine system, because in the real time, the single machine is not operating, but they are connected together in the grid fashion. And we have to check the system into grid fashion. And we got very interesting results here. You can see the results for different machines where they are interconnected together and the loads are also interconnected. So finally, the generalized neural network possible applications, intelligent robots may be developed, which have better capabilities for working and better performance, auto drive systems, motor speed controls, and cognition system. So recently we are working on the last one, cognitive systems for machine learning. So in conclusion, these generalized neural network models have been developed and implemented, validated on standard benchmark problems, used on real-time applications, and compared with conventional networks. And these are the few publications in the form of books. We have a modeling simulation book from CRC Press, soft computing book from Springer, and machines manual from Vikas publication, New Delhi. We have theology, science, and technology, again from Vikas publications. So these are the few books. And recently I'm writing another book on ethics and values with consciousness. So that's coming probably in the next month or so. So thank you very much. I would like to acknowledge my revered professor and mentor and my guru, Professor P. S. Satsangi, Chairman Advisory Committee in Education, who guided us to work in these areas. Thank you very much. If you have any question, anything, I hope I finished on time probably.
Participants having any question, you can ask with the Professor D.K. Chaturvedi, sir. Sir, one question is there from Amish Patel.
Yeah.
Amish, you can ask. Can you hear?
Unmute your mic.
Hello.
Yeah.
Sir, does the density of cloud make difference on the experiment that you have carried out?
Effect of clouds, right?
Yes, density.
Certainly, actually, when the clouds will come, we have to identify where the clouds are and at what time these clouds will come on your solar panel, in between the solar panel and the sun. Because if the clouds are there, but they are not coming in between, then there is no problem. But if the clouds are moving and they are coming in between the panel and the sun, then the reflections or the irradiation which are coming from the sun will be affected. So it will affect the solar power generation.
Yeah, that I am very clear, sir.
Yeah.
But what about the density? If there are
Yeah.
lighter clouds, then does it make the little difference? And if there are more dense, then it will make more difference. If I'm not wrong.
We have considered three types of clouds: white clouds, black clouds, and gray clouds. So the density of clouds or the darkness of clouds will also affect, along with their heights, how close these clouds from your solar panel, right? So we have considered that also, the percentage of cloud density along with the height. So I have not shown those results here due to the time limitations, but that is one of the PhD work of my student recently submitted.
Okay, thank you.
Okay. Anything else?
Any other question? I think there is no question.
Fine.
Okay, thank you very much, sir. You have given us time. Thank you, sir.
Thank you very much. Thank you very much to the organizers inviting me for this lecture. Thank you.
We will start next session shortly after 10 minutes. Good afternoon to everyone. Next session will be on holistic development and role of education, that will be delivered by Professor Arun Kumar Singh. And this is one of the mandatory session as prescribed by AICTE Atal scheme. We have to take one mandatory session on stress management on human values. So This will be delivered by Professor Arun Kumar Singh. He is BE in Electronics and Instrumentation from BIT Jhansi, MTech in Digital Electronics and PhD from Uttar Pradesh Technical University. Presently, he is working as Associate Professor and Head of Department in Department of Electronics Engineering. He is a member of various technical committees and organization like senior member of IEEE, life member of ISTE. He wrote many books having more than 20 years of teaching experience and research experience, and having various books. So I hope that all will be benefited by this session. So I would like to request Professor Arun Singh to start your presentation.
Thanks, Vivek, for inviting for me in this AICT ETEL FDP program. As you said that this is mandatory session and is on stress management. So I will try to cover a new way of thinking which will help all the human beings to achieve what they want in their life. So I am stopping my video because sometimes it makes disturbance and I am sharing my PPTs. As we are located in Harsi Kannauj, it is far location from the main cities, and here is no problem. So now I start my lecture, and I will deliver my lecture both in Hindi and English. My PPT is made in such a way that it covers both Hindi and English, and it will be benefited so that any person who is from who do not know English or understand English better way, because some terminologies in Hindi are difficult in my slide. Basically, this is not my slide. I am associated with Value Education Cell of EKTU and AICTE, and this is the same slide which all the resource persons are using and deliver, because the content is same. Simply, I am a tool or a person to deliver the message, or a person which is delivering you the message. The content is not written by me. It is a universal content which is developed by a team of persons, and they continuously evolve these contents. So let us start the talk. The topic of my talk is holistic development and role of education. So I am sharing my screen. Is the screen is visible to all of you? Hello.
Yes, sir.
Visible.
Okay. Then I am.
Yes, sir.
Okay. Thank you.
करेक्ट इसमें नहीं दिखाई नहीं हुई।
दिखाई दे रहा होगा. So what we are going to cover in this session? First of all, what is basic human aspiration? How we can fulfill the basic human aspiration? What do we mean by holistic development? And what is the role of education in holistic development? So in this session, we also cover what we are expected or achievement from right understanding. Because when we talk about holistic development or role of education, then we normally use the term right understanding. हमारा मेन इसका मकसद है कि हर मानव का, हम जब मानव की बात कर रहे हैं तो मानव में हम किसी एक आदमी की बात नहीं कर रहे हैं, हम पूरे जितने भी पृथ्वी में मानव सबकी बात कर रहे हैं. क्या सभी मानव का चाहना एक हो सकता है? क्या सभी मानव की चाहना की पूर्ति हो सकती है? क्या सभी ऐसा समाज हम विकसित कर सकते हैं जिसमें समग्र विकास हो पाए? और अगर ऐसा पॉसिबल है तो समग्र विकास में शिक्षा की क्या भूमिका होनी चाहिए या क्या भूमिका है? और इस सत्र से हम ये भी कोशिश करेंगे, क्योंकि सत्र केवल 90 मिनट का है, तो इस सत्र में हम कोशिश करेंगे कि आपको एक ओवरव्यू मिल जाए, जिससे अगर आप उसको फ्यूचर में जब भी आपको टाइम मिलता है, जब भी आपको उसकी जरूरत महसूस होती है, you can explore it, this content, because this content is not simply in sermon way. I cannot sermon that you can do this or you cannot do this, or by doing this you will be happy, or by not doing this you will be not happy. So this is for all the persons, all the human beings, to develop right understanding in themselves. And by developing right understanding, they may achieve happiness forever. So all what we are going to tell in this session is in the form of a proposal. Do not assume it to be true or false, but you have to verify it on your own right and on your natural acceptance. जो भी हम यहाँ पे कह रहे हैं उसे आप सिंपली आंख बंद करके न माने, बल्कि उसे स्वयं के अधिकार पे जांचें और अपनी सहज स्वीकृति के आधार पर उसको एक्सेप्ट करें, स्वीकार करें. क्योंकि अगर वो आपकी सहज स्वीकृति के आधार पे नहीं है तो आप उसे मानने के लिए बाध्य नहीं हो सकते. हो सकता है किसी प्रेशर के अंदर पे आप किसी चीज को कभी मान लें, लेकिन आप उसको एक्सेप्ट कर पाएंगे या अपने में आत्मसात कर पाएंगे, ये पॉसिबल नहीं है. So how this process starts? When I give you a proposal, it is a dialogue between me and you. This is the basic to start with. But soon it becomes a dialogue within yourself. क्योंकि ये निरंतर संवाद की प्रक्रिया है. ये ऐसा नहीं है कि एक बार बता दिया गया तो वो सही है, दूसरी बार आप उसको ले सकते हैं, क्योंकि ये चीज जो नेचुरल एक्सेप्टेंस है, जो सहज स्वीकृति है, वह सभी काल परिस्थिति में सेम होगी, वो काल परिस्थिति के हिसाब से बदलती नहीं है। So the purpose of this session is to initiate this internal dialogue within yourself. So let us start. तो क्या हम सुखी होना चाहते हैं? Do we want to be happy? Do we want to be prosperous? Do we want the continuity of happiness as prosperity? मुझे लगता है कि इसका आंसर सभी को अपने में सोचना चाहिए। और आप इसको देख सकते हैं, क्योंकि ये सेशन ऑनलाइन मोड में चल रहा है, नहीं तो ऑफलाइन मोड में नॉर्मली हम लोग जब 1-to-1 इंटरेक्ट करते हैं, देन वी इंटरेक्ट विथ ईच एंड एवरी पार्टिसिपेंट एंड आस्क देम व्हाट इज देयर आंसर। आई थिंक यू शुड राइट व्हाट डू यू वांट टू बी हैप्पी, डू यू वांट टू बी प्रॉस्परस, or do we want the continuity of happiness or prosperity, or opposite of it? क्या आप दुखी होना चाह रहे हैं? क्या आप दरिद्र होना चाहते हैं? या आप कभी सुखी होना चाहते हैं, कभी दुखी होना चाहते हैं? या कभी आप समृद्ध होना चाहते हैं, कभी दरिद्र होना चाहते हैं? या आप चाहते नहीं कभी तो हमको सुखी चाहिए, कभी तो हमको दुखी होना चलेगा? ऐसा भी चल सकता है। ये आंसर आप अपने में देख सकते हैं कि आप क्या चाहते हैं। ये तो हमारा चाहना हो गया। अब हम ये देख लें कि हमारी पोजीशन क्या है आज की डेट में, हमारा स्टेटस क्या है, हमारा हम किस स्टेट में जी रहे हैं। आर वी हैप्पी, आर वी प्रॉस्पेरस, एंड इज देयर कंटिन्यूटी ऑफ आवर हैप्पीनेस एंड prosperity? I think all of you can judge in which state you are and how we can move from, if we are in the state of happiness, we feel ourselves as prosperous, and we see that we are in continuous state of happiness and prosperity, then you can live in that way. Otherwise you have to think otherwise. How we are happy forever, we are prosperous, and we can able to make this happiness and prosperity and its continuity in our life. And if there is any gap between your desire and your current state, then we have to see why this gap is there in our desire and our current state. Why this gap is between what we really want to be and what we are. And what we are doing to fill this gap. Is it getting filled up or getting wider with time as we become older? We will try to explore into this. Because our desire is to be happy, to be prosperous, and its continuity. So, is our effort is for continuity of happiness and prosperity, or simply just accumulation of physical facility? And we think that by accumulating more and more physical facility, we will be more happy and more prosperous. Have you assumed, or we assume that happiness and prosperity will be ensured when we have enough physical facility then what effort are we making to accumulate this physical facility? Is it necessary? Is it is more than necessary? Are we only effort for accumulating physical facility? And if otherwise, to make ourselves happy and prosperous and be continuity for being the continuity of happiness and prosperity, we are making some other effort. Other than the accumulation of physical facility. This is a point which all of us should see in ourselves. So, is physical facility is necessary? The answer is definitely yes. We cannot say that without physical facility, we will be comfortable. But is it complete? The answer, all of us have to be searched. Because when an animal has lack of physical facility, it becomes uncomfortable. And as soon as it gets physical facility, it becomes comfortable. जैसे कि किसी पशु को अगर सुविधा का अभाव होता है तो वो परेशान होता है, सुविधा मिल जाए तो वो आराम में आ जाता है। जैसे हम किसी गाय की बात करें, अगर उसे पेट भर घास मिल जाए तो गाय आराम से चुगाली करती रहती है। क्या आदमी के बारे में, ह्यूमन बीइंग के बारे में, इट इज ट्रू। The same thing is applicable for human being. The lack of physical facility makes him uncomfortable and unhappy. But once he gets the physical facility, he forgets about it and starts thinking about 100 other things. जब हम भूखे होते हैं तब परेशान होते हैं, लेकिन एक बार खाना मिल जाए तो हमारा ध्यान खाने से हटके 100 ऐसी चीजों पे चला जाता है जो कि उस समय उतनी महत्व की नहीं होती है। उस समय हम ये भूल जाते हैं कि खाना हमारी जरूरत है और ये मान बैठते हैं कि ये तो होना ही है, अब आगे की और क्या। ये आप देख लीजिए, क्या आपको खाना मिलने के बाद आप सुखी महसूस करते हैं कि आपको डेली सही मात्रा में सही पोषक तत्व के साथ भोजन उपलब्ध है। By seeing and experiencing that, after getting the enough facility, we are happy, or still something is more required. As we see that physical facility is also necessary for human being, as it is necessary for animals, but for human being something more is required. When we go into the family and see the cause of unhappiness in our family, what you will observe, what you will see, you see that and experience that is more due to the lack of physical facility, or it is more due to the lack of fulfillment in relationship. आप सभी जब भी अपने परिवार की तरफ देखते हैं या देखें तो आप ये देखने की कोशिश करें कि आपके परिवार में अगर सुख का अभाव है तो उसका रीजन क्या है? वो फिजिकल फैसिलिटी की वजह से है, सुविधा के अभाव की वजह से है, या रिलेशनशिप में संबंधों का सही तरीके से निर्वाह न करने के कारण ज्यादा है। अगर it is more due to the lack of fulfillment in relationship and you continuous try to gap this by accumulating more and more physical facility, it is going to fill the gap. You have to see the answer, because as we said in the initial slide, हम आपके सामने तथ्यों को रख रहे हैं। ये अब आपको डिसाइड करना है अपने नेचुरल एक्सेप्टेंस के ऊपर, जांच के, समझ के, कि जो बातें यहाँ कही जा रही क्या वो सही हैं, और अगर सही हैं तो उनको अपने जीवन में निर्वाह करके आप सुख और समृद्धता का अनुभव कर सकते हैं। अगर नहीं सही है तो इसका मतलब हमें कुछ और चीजों को समझने की जरूरत है, समझ डेवलप करने की जरूरत है। उस समझ के साथ फिर जीने जाते हैं और देखते हैं कि क्या वो सही है। इस तरीके से ये निरंतर चलने वाली प्रक्रिया है, जिसमें हम पहले किसी चीज को समझते हैं, समझ के उसको जीने जाते हैं। अगर उस तरीके से जीने से एक मिनट, अभी मैं इसको कॉल कर रहा हूँ, एक फोन आ रहा है, जरा उसको आप देख के। तो अगर आप ये देखने जाते हैं तो आपको समझ में आता है कि कहीं ना कहीं फिजिकल फैसिलिटी तो जरूरी है, लेकिन उससे भी ज्यादा जरूरी है संबंधों का निर्वाह, फुलफिलमेंट इन रिलेशनशिप। As we said that if the happiness is more due to the lack of fulfillment in relationship, then it cannot be covered by effort more in the direction of accumulating physical facility. But what we see that most of the time our effort is spent for physical facility. दुख संबंध का निर्वाह न होने के कारण ज्यादा है, परंतु समय व प्रयास सुविधा के लिए ज्यादा लगाया जा रहा है। तो यह एक प्रस्ताव है जिसे आप अपने ऊपर देख सकते हैं और फिर अपने अंदर राइट अंडरस्टैंडिंग डेवलप करके इस गैप को फिल करने का प्रयास किया जा सकता है, क्योंकि स्ट्रेस और डिप्रेशन जो आज की डेट में बहुत कॉमन प्रचलित शब्द हो गए हैं कि मैं तो बहुत स्ट्रेस में हूं, मैं तो डिप्रेशन में चला गया था, या तो मैं तो डिप्रेशन में चला गया हूं, या हमारे जानने वालों में डिप्रेशन में चले गए हैं। तो जब स्ट्रेस और डिप्रेशन की हम बात करते हैं तो उसका रीजन क्या है? व्हाट इज द रीजन बिहाइंड स्ट्रेस एंड डिप्रेशन? Is it is due to the lack of physical facility, or due to the lack of fulfillment in relationship? This all we have to see. So we can summarize that for human being, physical facility is necessary, but relationship is also necessary. और अगर हम बहुत ध्यान से देखें तो यही एक बेसिक डिफरेंस जीव चेतना और मानव चेतना के बीच में समझ में आता है। On examining carefully, we find that this is the fundamental difference between animals and human beings. Physical facility is necessary for animals, and it is also necessary for human being. तो ये आप सभी अपने अंदर जांच के देख लें कि अभी तक जितनी बातें आपके सामने रखी गई हैं, क्या आप उससे सहमत हैं या असहमत हैं? आप चाहें तो चैट बॉक्स में अपने क्वेश्चंस पुट कर सकते हैं और हम कोशिश करेंगे कि उसका जवाब आप तक पहुंचाया जा सके। लेकिन जैसा कि सेशन शुरुआत होने के पहले ही बताया कि यह एक प्रस्ताव है, दिस इज ए प्रपोजल, दिस इज नॉट ए moral education type of thing. You can judge it by living it. आप जी के इसको देख सकते हैं। यदि जीने में इससे आपको सुख और समृद्धि का अनुभव होता है तो आप उसको कंटिन्यू कर सकते हैं। अदरवाइज you may go for some more understanding, विषय का बारे में और समझ के बारे में जा सकते हैं और उसके बाद उसको जीने की कोशिश की जा सकती है। So we can conclude that up to now that for animals physical facility is necessary as well as adequate. पशुओं के लिए सुविधा आवश्यक भी है और पूर्ण भी है। For human being, physical facility is necessary, but it is not adequate. So what is that other things which is additional to physical facility? That thing is relationship, relation with human being. यदि आप संबंध पूर्वक नेसेसरी फिजिकल फैसिलिटी के साथ परिवार में जीने जाते हैं तो आप अपने को सुखी महसूस करते हैं और समृद्ध महसूस करते हैं। Sometimes we say that in relationship there must be arguments, there must be opposition and fights. Without its, life becomes monotonous, and many words we are using. And also, sometimes we do get into arguments and opposition and fights, not only in the family, but with our close friends, our colleagues, and in marketplace and itself. Every time we have a fight, we want to resolve it. We say sorry, patch up, and promise not to fight in future. But even though we do not want to, a fight does take place once again. What is the reason behind this? The reason is that we simply see that the argument is, or the opposition is, due to the other side of the people, not due to me. As we do not see that, it may be due to myself. We always pass the onus to the other. And to improve or to resolve this, we want the other to improve, not ourselves. And the same things is also experienced by the other side. The other wants to improve us, not themselves. You can see this. Is this happening in your life? You can see in the society or incident of reaction, not speaking to the other, arguments, debates, divorce, increasing or decreasing day by day. So it is proposal from our side to all of you to explore your close relationships in the family, with friends, in the workplace, in the society. So in spite of our acceptance for relationship, why this is happening? We have to give a thought on this. Unless we give a thought on this, we cannot going to improve it. जब हम समाज में भय की बात करते हैं तो भय कितने प्रकार से हो सकते हैं। अगर हम आज से 100 साल पहले तक की बात करें तो किस प्रकार का भय प्रमुख था और आज किस प्रकार का भय प्रमुख है। When we want to see the fear, then we can see which one is predominant for us. Fear of natural calamities, fear of wild animals, or fear of inhuman behavior of human beings. तो आप सभी इसको आपस में देख सकते हैं, अपने में देख सकते हैं, समाज में देख सकते हैं, परिवार में देख सकते हैं कि किस प्रकार के भय से आपको ज्यादा भय लगता है। नेचुरल कैलेमिटीज से, वाइल्ड एनिमल्स से, या इनह्यूमन बिहेवियर ऑफ ह्यूमन बींग्स, या घर के किसी सदस्य के इनह्यूमन बिहेवियर से। अगर हम परिवार में देखने जाएं, यदि हम समाज में देखने जाएं तो आपको किस चीज का भय ज्यादा है आज की डेट में। क्योंकि कुछ चीजें आज से कुछ दशक पहले, कुछ शताब्दी पहले किसी प्रकार का भय प्रीडोमिनेंट स्टेट में हो सकता था, और आज की डेट में हमें देखने की जरूरत है किस प्रकार का भय ज्यादा है। तो जब हम आज के समाज में देखने जाते हैं तो हिंसक पशुओं का भय या फियर ऑफ वाइल्ड एनिमल्स लगभग खत्म हो चुका है, बल्कि इसका अपोजिट ही ज्यादा देखने में आ रहा है कि पशु भी इंसान से ज्यादा डर रहे हैं। तो ये तो देखने का विषय है कि कौन ज्यादा वाइल्ड है, ह्यूमन और वाइल्ड एनिमल। विद द advancement in technology, we have almost minimized the fear of natural calamities. तकनीक के विकास के साथ प्राकृतिक आपदा का समय से पहले अनुमान हो जाने से उसका भय भी अब उतना नहीं रह गया जितना आज से कुछ दशकों या कुछ वर्षों पहले तक था। लेकिन जैसे जैसे हम अपने को एक शिक्षित समाज की तरफ लेते जा रहे हैं तो एक नए तरीके का भय ज्यादा ही होता जा रहा है। वो है मानव के अमानवीय व्यवहार का भय, जिसे आप सभी देख भी सकते हैं और समझ भी सकते हैं। अगर न्यूज चैनलों की बात करें या सोशल मीडिया में बात करें तो आप इस चीज को अपने में महसूस कर सकते हैं कि आज के डेट में समाज में किस प्रकार का भय या फियर डोमिनेंट है। तो जो चीज देखने में आ रही है, द फियर ऑफ इनह्यूमन बिहेवियर ऑफ ह्यूमन बीइंग, मैं बहुत उसमें नहीं जा रहा हूं, लेकिन न्यूज अगर आप देखने जाते हैं तो 10 में से 9 न्यूज इनह्यूमन बिहेवियर ऑफ ह्यूमन बीइंग्स की ही होती है। तो ये किसका अभाव है? ये शिक्षा का अभाव है, क्योंकि शिक्षा की जब हम बात करने जाते हैं तो हम तो कहते हैं कि हमारे पास डिग्रीज बढ़ती जा रही है, और जब इन ह्यूमन बिहेवियर की बात करने जाते हैं तो हम देखते हैं कि वो आदमी भी उस कृत्य में लिप्त पाया जा रहा है जिसके पास डिग्री में लेने के लिए इससे ज्यादा कुछ बचा नहीं है। वो पीएचडी, डीलिट, फीलिट, जितनी डिग्री की आप बात कर सकते हैं, सब होने के बाद भी वो कहीं ना कहीं बिहेवियर वाइज, जो कि एक सभ्य समाज में ह्यूमन बीइंग से एक्सेप्ट की जाती हैं, नहीं जी पा रहा है। अभी एक बहुत बड़े ऑफिसर्स का केस आया था एमपी का, जो सभी ने वीडियो देखा। अभी कुछ जो चल रहा है डेली न्यूज़ों पे हाथरस और आसपास का, वो सभी आप लोग देख ही रहे हैं। तो ये एक बहुत बड़े भय का कारण है इन ह्यूमन बिहेवियर ऑफ ह्यूमन बीइंग्स, जिसे आप अपने अंदर जांच लें, देख सकते हैं। और आप ये भी देख सकते हैं ये भय बढ़ रहा है या घट रहा है। जैसे जैसे हम ज्यादा शिक्षित होते जा रहे हैं, जैसे जैसे हम अपने को एक सिविलाइज सोसाइटी का नाम दे रहे हैं, तो क्या ये भय बढ़ रहा है या घट रहा है? इज दिस फियर is on the increasing side or on decreasing side? So, in spite of our acceptance for relationship, why do we have such a state of affairs? That's why we have, it becomes necessary for all of us to check our perspective about relationship. यही कारण है कि हमको दोबारा से अपने अंदर संबंध को लेके हमारा क्या पर्सपेक्टिव है उसको जांचने की जरूरत है। Let us find out it. We want to live in relationship with others. क्या आपकी चाहना संबंध पूर्वक जीने की है? और we want to live in opposition with others, या आपकी चाहना विरोध पूर्वक जीने की है? Or we think otherwise, that is, we believe that living has to be necessarily in opposition with others, that is, there is struggle for survival, survival of the fittest. Then it is up to we to check if we feel happy living in this way. या तो आपने मान रखा है कि जीना तो विरोध पूर्वक ही संभव है, स्ट्रगल फॉर सर्वाइवल, सर्वाइवल ऑफ द फिटेस्ट। तो ये आप अपने में देख सकते हैं, क्या आप वैसा जीते हुए सुखी होते हैं? So, what is our present perspective? We have to think. Which view do we propagate? At home, in family, in schools and colleges, and in the society? Is it necessarily an acceptable view? So, for fulfillment in relationship, it is necessary to have right understanding about relationship. That is, right understanding is also necessary for human being. So what with right understanding, what we achieve with right understanding, what we are going to see in ourselves by right understanding. So with right understanding, we have clarity about relationship with human being, and with that clarity, we are able to fulfill relationship. And with this right understanding, we also have clarity about how much physical facility we need. Otherwise, we keep accumulating more and more physical facility and try to fill the gap in relationship with accumulating more and more physical facility. So what we can see that right understanding is also essential for human being. Not only the relationship, not only physical facility, but also the right relationship. अपने अंदर सही समझ को विकसित करते हुए, डेवलप करते हुए, सही या आवश्यक सुविधाओं का संग्रह करते हुए संबंध में जब हम जीने जाते हैं, तो हम अपने को सुखी महसूस कर सकते हैं, अपने को समृद्ध महसूस कर सकते हैं. Or you people can see it, is all of these three is necessary, or you can leave any one of it and be in the state of happiness. You can leave right understanding, you can leave relationship, or you are unable to get necessary physical facility for living a life. And if you think we have some more things required to live a happy and prosperous life. क्या हम इसमें से कुछ को हटा के सुखी और समृद्ध पूर्वक रह सकते हैं, जी सकते हैं, या सुखी और समृद्ध पूर्वक जीने के लिए इन तीन चीजों के अलावा भी अभी किसी और चीज की जरूरत है? जब हम जीने जाते हैं तो हम ये देखते हैं कि इन तीनों में क्या क्रम होना चाहिए. क्या हमारी पहली प्रायोरिटी फिजिकल फैसिलिटी एक्युमुलेट करने की होनी चाहिए, या हमारी प्रायोरिटी संबंध में जीने की होनी चाहिए, या हमारी हाईएस्ट प्रायोरिटी अपने अंदर सही समझ डेवलप करने की होनी चाहिए. You people can arrange it in the order of priority and see which order you have chosen. From your point of view, which one is more important? Is it right understanding, or physical facility, or relationship? अब हम ये भी देखने जाएं कि क्या हम तीनों पे काम कर रहे हैं? Are we are working on all these three? That is physical facility, relationship, and right understanding? Or we are simply putting all our effort to accumulate more and more physical facility without giving importance to relationship or without putting effort for right understanding. So working on the high priority, if we able to fix a sequence, and if it is a right sequence, then by working on the high priority makes it easier to deal with the lower priority. But first of all, we have to make a sequence or priority sequence which is necessary to fill a happy and prosperous life. We are proposing the priority sequence. First is right understanding, second is relationship, and third is physical facility. We are not said that you will be happy and prosperous or your feeling will be happiness. If you do not have a physical facility or you do not have a relationship. तो सही समझ के साथ संबंधों का निर्वाह करते हुए आवश्यक सुविधाओं के साथ हम अपने को सुखी और समृद्ध कर सकते हैं, या आपका ऐसा सोचना है कि केवल फिजिकल फैसिलिटी से ही काम चल सकता है। या आप अपने ऊपर जांच के देख सकते हैं और अपने इस समझ के साथ आप उसको अपने जीने में देखिए। अगर आपको लगता है कि फिजिकल फैसिलिटी को पहले नंबर पे होना चाहिए तो आप उसके हिसाब से जीने को देखिए। रिलेशनशिप और राइट अंडरस्टैंडिंग को अभी आप छोड़ सकते हैं, या इन तीनों के बिना ही आपका काम नहीं चलने वाला है। ये तो आपको डिसाइड करना पड़ेगा। We have to decide whether only with the physical facility or giving the more priority for the accumulation of physical facility, we can be prosperous and happy. जब हम बिना सही समझ के दूसरों के साथ पेश होते हैं, संबंध में होते हैं, तो हम न सुख का अनुभव खुद में कर पाते हैं न दूसरों को सुखी कर पाते हैं। और अगर हम बिना सही समझ के केवल फिजिकल फैसिलिटी को रिलेट करने जाते हैं तो हम अपने अंदर समृद्धता का अनुभव नहीं कर पाते हैं। अगर आप समृद्ध नहीं है तो इसका अपोजिट क्या? अगर आप समृद्ध नहीं है तो भाव तो समृद्धता का होना चाहिए। अगर वो भाव आपके अंदर नहीं है, if you do not feel prosperous, then your act will be exploiting and depriving others. Your act will lead to the deprivation. आप दूसरों के हिस्से के भी सुख सुविधाओं का संग्रह अपने लिए कर लेंगे, जिसका उपयोग आप अपने लिए भी नहीं कर पा रहे हैं। अगर हम एक सिंपल एग्जाम्पल की बात करें, तो अगर आपको खाने में रसगुल्ले पसंद है और आपको खाने की आपकी क्षमता भी अच्छी है, आप 5, 10, 15, 20 रसगुल्ले खा सकते हैं, तो हम शुरुआत में तो उसका स्वाद अच्छा लगता है, लेकिन एक स्टेज के बाद अगर हम आपको, जब आपका पेट भर जाए, फिर हम आपको खाने को कहें तो वही अच्छी चीज भी आपको स्वादिष्ट नहीं लगती। तो फिजिकल फैसिलिटी के बारे में भी ऐसा ही है। फिजिकल फैसिलिटी आवश्यक है, लेकिन एक मात्रा के ज्यादा उसका संग्रह आपको हैप्पीनेस के स्टेट में नहीं ले जाता है। ये आप अपने अंदर देख सकते हैं। तो अगर हम देखने जाते हैं तो प्रायोरिटी क्या होनी चाहिए? अगर आप बिना सही समझ के संबंधों में जाते हैं तो संबंधों का निर्वाह करने में आपको प्रॉब्लम हो रही है। बिना सही समझ के आप फिजिकल सुविधाओं का संग्रह करने जा रहे हैं तो आप दूसरों के लिए भी अच्छी स्थिति पैदा नहीं कर रहे हैं। तो सबसे महत्वपूर्ण चीज तो हो गई अपने अंदर सही समझ डेवलप करना। आप अपने अंदर सही समझ डेवलप करके ही संबंधों में जी सकते हैं, और अगर आप अपने अंदर सही समझ के साथ संबंधों में जीने जाते हैं तो म्यूचुअल हैप्पीनेस की स्टेट होती है, जिसे हम उभय सुख बोलते हैं। इससे आप तो सुखी होते ही हैं, सामने वाला भी सुखी होता है। और अगर सही समझ के साथ आप फिजिकल फैसिलिटी को एक्युमुलेट करते हैं, उसका उत्पादन करते हैं, उसका संग्रह करते हैं, तो इससे आप अपने अंदर तो समृद्धता का भाव लाते ही हैं, सामने वाले को भी समृद्धता का भाव आता है। विवेक जी, शेयरिंग में कुछ प्रॉब्लम आ रही है?
Yes, sir. I will share.
प्रॉब्लम आ रही है शेयरिंग की?
I made you host. You can share now.
अच्छा अच्छा। ठीक है, शेयरिंग हो गई प्रॉपर। तो इसी क्रम को जब हम संपूर्णता में देखते हैं, दैट इज राइट अंडरस्टैंडिंग, रिलेशनशिप, फिजिकल फैसिलिटी, इसी को नाम दिया गया है ह्यूमन कॉन्शियसनेस, मानव चेतना। मानव चेतना के साथ जब भी हम जीने चाहते हैं, मानव चेतना मतलब सही समझ के साथ, सही संबंध के भाव के साथ, सही सुविधा संग्रह के साथ जब हम जीने चाहते हैं, तो हम अपने को, अपने सगी संबंधियों को सुखी कर पाते हैं और अपने अंदर सुख और समृद्धता का भाव ले पाते हैं। That is, if we are living with all three, right understanding, relationship, and physical facility in that priority order, then we are living with human consciousness. And human being can be fulfilled, that is, be happy and prosperous on the basis of these three. और अगर हम ह्यूमन कॉन्शियसनेस में नहीं है और केवल फिजिकल फैसिलिटी पे हमारा पूरा ध्यान है, तो इसको नाम दिया गया है एनिमल कॉन्शियसनेस, दैट आर जीव चेतना। अगर हम मानवीय चेतना में नहीं हैं और केवल जीव चेतना में जी रहे हैं, तो हम निरंतर सुख और समृद्धि का अनुभव कर पा रहे हैं या नहीं, ये आप देख सकते हैं। That is, if our living is only for physical facility, then we are living with animal consciousness. Since we all know that animals live only for physical facility and can be fulfilled by that, while human being cannot be fulfilled on the basis of physical facility alone. Normally we see that generally we do not have clarity about our physical needs, क्योंकि कभी हमने अपनी फिजिकल नीड्स के बारे में बहुत गहराई से नहीं सोचा, तो इसलिए हम सामान्यतः ज्यादा से ज्यादा भौतिक सुविधाओं का संग्रह करने में लगे रहते हैं। And on that basis, in the society, we can observe two categories of human beings. इसलिए अभी दो तरह के मनुष्य दिखाई देते हैं। एक तो वो who have lacking physical facility and are unhappy and deprived, जो कि सुविधा विहीन है, दुखी हैं और दरिद्र हैं। लेकिन इसके साथ ही साथ अलग तरीके के लोग भी दिखाई देते हैं जिनके पास सफिशिएंट फिजिकल फैसिलिटी है, उसके बाद भी वो अपने को दरिद्र महसूस करते हैं। अदर आर हैविंग सफिशिएंट फिजिकल फैसिलिटी बट दे आर अनहैप्पी एंड डिप्राइव्ड। जबकि सभी मनुष्यों का लक्ष्य क्या था? सभी मनुष्य सुविधा संपन्न होना चाहते हैं और प्रॉस्परस होना चाहते हैं। We can check our state. Either we are at first stage or we are in the second stage or we are in the third stage. हम अपने अंदर ये जांच के देख सकते हैं कि अभी हम किस स्टेज पे हैं, क्योंकि हम होना तो थर्ड स्टेज में ही चाहते हैं कि हमारे अंदर सुविधा संपन्न भी हो, सुखी भी हो, समृद्ध भी हो। क्या हम आज उस स्थिति में अपने को देख पा रहे हैं कि हम सुविधा संपन्न सुखी समृद्ध हैं, या सुविधा संपन्न दुखी दरिद्र हैं, या सुविधा विहीन दुखी दरिद्र हैं? क्योंकि जब तक हम अपनी स्थिति को का सही आकलन नहीं कर लेते हैं, तब तक दूसरी सही स्थिति में पहुंचने की संभावना भी बहुत कम रहती है। तो सबसे जरूरी है कि हम सही आकलन कर पाए, और आकलन करने के लिए सही समझ का होना जरूरी है। As we all know that resources are not the problem. Resources का कभी भी अभाव नहीं रहा। पूरी मानव सभ्यता में अगर हम देखने जाते हैं तो रिसोर्सेज का अभाव कभी न रहा। कुछ लोगों के रिसोर्सेज के सही यूटिलाइजेशन न करने की वजह से ही पूरे विश्व में भुखमरी का आलम है। नॉर्मली हम कहते हैं कि सही उत्पादन नहीं हो पा रहा है, इस वजह से लोग भुखमरी हो रहे हैं, लेकिन ऐसा नहीं है। Contrary to the population opinion, malnutrition and starvation are not the result of overpopulation or a poor climate or lack of cultivable land. As we know that global food production is even this time is 6 times more than the requirement. But global wastage is also 1/3 of the production. This wastage is enough to feed 1,300 crore people per year. Although we are quoting the UN-backed report way back of 11th May 2011, but this is true at present also. that is about 1/3 of the all food produced for human consumption each year, or roughly 1.3 billion tons, is lost or wasted. If we are anyway or somehow utilized this wasted food product, we will be able to feed the each and every people on the earth. So it is not the resources, but it is due to the planning and proper understanding. So here we see क्या हम सही समझ सही यूटिलाइजेशन को देख पाए हैं, या ये प्रोडक्शन का प्रश्न है, या ये सही डिस्ट्रीब्यूशन का प्रश्न है कि अगर सही डिस्ट्रीब्यूशन होता तो सभी आदमियों को सही मात्रा में अन्न का डिस्ट्रीब्यूशन हो पाता, या हम संबंधों के अभाव के कारण इसको नहीं देख पा रहे हैं, या ये हमारे अंदर सही समझ का अभाव है। Yeah, it is a question of education. We have to see it. So, we can summarize the talk up to now. Animal living with animal consciousness. जीव चेतना की जो हम बात कर रहे थे, अगर जीव जीव चेतना में जी रहा है तो वो हार्मनी के साथ है, then they are in harmony, और ये सही भी है, this is fine, there is no problem in this. अगर मनुष्य चेतना में जी रहा है, if human being living with human consciousness, this is also fine, and they all are in harmony. The problem arises when human being started to live with animal consciousness. This lead to disharmony, and this is the problem. मनुष्य का जीव चेतना में जीना ये अपने में एक समस्या है। तो अगर हम देखने जाएं तो हम जिसको होलिस्टिक डेवलपमेंट या समग्र विकास बोल रहे हैं, तो वो है क्या? समग्र विकास को अगर हम समराइज करें तो वो सिंपली संक्रमण है जीव चेतना से मानव चेतना की तरफ। द ट्रांसफॉर्मेशन या ट्रांजिशन फ्रॉम एनिमल कॉन्शियसनेस टू ह्यूमन कॉन्शियसनेस। और यही शिक्षा का उद्देश्य होना चाहिए, या यही शिक्षा का उद्देश्य है। जब हम डेवलपमेंट की बात करते हैं, इज दिस डेवलपमेंट जस्ट इन इंक्रीजिंग फिजिकल फैसिलिटी, or development in ensuring all of three, that is right understanding, relationship, physical facility? हम कितना समय दे रहे हैं इन तीनों को? अपनी समझ को बढ़ाने के लिए, संबंध में जीने के लिए, और फिजिकल फैसिलिटी का संग्रह करने के लिए। तो क्या जीव चेतना से मानव चेतना की तरह जाना जरूरी है, या यही विकास है? ये आप देख सकते हैं। जब हम विकास या प्रोग्रेस की बात करते हैं तो प्रोग्रेस का सही अर्थ है जीव चेतना से मानव चेतना की तरफ संक्रमण। Now we have to see, are we making effort for it, या हमने इसको ऐसे ही छोड़ रखा है कि ये तो अपने आप हो ही जाएगा, अभी हम सुविधा संग्रह कर लेते हैं, समझ और संबंध तो समय के साथ हो ही जाएगा। We have to see it, or do we need to make effort for it, या ये अपने आप हो जाएगा कि या हमें इसके लिए प्रयास करने की जरूरत है। If time permit, then we will explore it in detail. Otherwise, I have around 20 to 20 minutes. So, what is the role of education sanskar? The role of education or sanskar is to enable this transformation from animal consciousness to human consciousness. The role of education or sanskar is to enable this transformation by way of ensuring the development of competence. I want to again say, ensuring the development of the competence to live with human consciousness and definite human conduct. इस पूरे वार्तालाप में शब्दों का बहुत महत्व है। शब्दों को ऐसे ही यूज नहीं किया जा रहा है। Each and every word have a definite meaning in definite context. So we have to see the meaning of that word in that context. नहीं तो नॉर्मली होता क्या है कि हम किसी शब्द को किसी भी अलग अर्थ में यूज करते रहते हैं और मान के चलते हैं वो सही है। So what is the role of education? As we have already said, the role of education or sanskar is to enable the transformation by way of ensuring the development of competence. आपके अंदर उस क्षमता का विकास करना जिससे आप ह्यूमन कॉन्शियसनेस में रह पाए और एक डिफिनिट मानवीय आचरण का पालन कर पाए। So how we are going to achieve this? For achieving this, it has to ensure that each and every child have right understanding. In every human being, the capacity to live in relationship with the other human being, and the capacity to identify the need of physical facility and the skills and practice for sustainable production of more than what is required, leading to the feeling of prosperity. जब हम आज की स्थिति को देखने जाते हैं तो क्या पाते हैं? Right understanding in every child, what is present state? Missing. I am not talking about some, I am talking about every child. Can we identify the capacity to live in the relationship with the other human being? Also, we see that it is missing in present state. Can we see the capacity to identify the need of physical facility, the required skills and practice for sustainable production of the more than what is required, leading to the feeling of prosperity? When we see it, we find that the identification part is missing. That is, the need of physical facility is missing. One more new trend is coming in the way that the willingness to produce by way of labor is also missing. But the core feeling generated is to accumulate more and more, to consume more and more, rather than to produce more and more. This is the problem. So, most of the problems we see around us are really only the symptoms of the human being not living with human consciousness. जब हम गहराई से सोचते हैं तो ये समझ में आता है कि ये सब प्रॉब्लम ह्यूमन कॉन्शियसनेस की है. So the basic effort is required to ensure human consciousness through human education. That is human education, which develop human consciousness, which inculcate human values, by which we ensure human conduct, definite human conduct, and develop a better human society, have definite human character. So this is the basic role of education, which is we see is missing in current education. The new education policy, I think I can mention it here because it is relevant. In new education policy, the more emphasis is given on holistic development. Let us see how it can be inculcated in our curriculum. Only time will tell. But the focus is on this holistic development. There is a lot of references that in current education we miss this part, and it must be included. So if we work in this direction, then ultimately it will result in a human tradition in which the human goals is fulfilled for all, generation after generation. So the outcome of human education or sanskar is understanding of harmony, that is harmony in human being, harmony in family, harmony in society, and overall harmony in nature and existence. This is guided by values. That is, when skills guided by values, it will lead to living in harmony as an individual, in the family, in the society, and after all in nature and existence. So skill is needed, but when it is guided by values, it will fulfill the human aspiration, that is to be happy and prosperous. यदि हम इसके साथ जीने जाते हैं तो अपने अंदर अपने सगे संबंधियों को सभी के साथ उभय समृद्धि और उभय सुख म्यूचुअल हैप्पीनेस एंड म्यूचुअल प्रॉस्पेरिटी को अचीव कर पाते हैं। तो शिक्षा का मुख्य उद्देश्य है अपने अंदर समझ को डेवलप करना, और जब हम संस्कार बोल रहे हैं उसको है कि उस संस्कार उस समझ के साथ जीने जाना। When we are talking about education sanskar means with right understanding we are living to achieve harmony at all the levels of human being it individual, family, society or existence. And the role of education must be to help in understanding harmony, that is harmony in human being, harmony in family, harmony in society, harmony in nature and existence. If then what will be the social implications of living with human consciousness? यदि हम सही समझ के साथ सही संबंध भाव के साथ जीने जाते हैं तो समाज में समृद्धता का भाव, प्रसन्नता का भाव आता है, which is the need of current scenario. आज के समाज में जो सबसे ज्यादा मिसिंग पार्ट है वो है divided society and unhappiness. It can only be achieved by proper शिक्षा संस्कार, proper education संस्कार। तो अब हम इसको अगर समराइज करने जाएं तो रोल ऑफ एजुकेशन शिक्षा संस्कार का सही आकलन तभी किया जा सकता है जब वो एक ह्यूमन के बीच में सही समझ डेवलप कर पाए, प्रॉस्पेरिटी ला पाए, फेयरनेस ला पाए और साथ ही साथ को एग्जिस्टेंस में जीने का भाव दे पाए। नहीं तो ये सोसाइटी एक भीड़ के सिवा कुछ नहीं रह पाएगी। अगर हम केवल अभी भी फिजिकल फैसिलिटी को ही एक्युमुलेट करने में रह जाते हैं तो सिनेरियो बहुत अच्छा नहीं रहेगा। तो अब ये समय है कि हम लोग अपने अंदर सही समझ के साथ, सही भाव के साथ आवश्यक सुविधा संग्रह करते हुए समाज में जीने जाएं, जिससे न केवल हम सुखी हों, साथ ही साथ हमारे सगे संबंधी भी सुखी हो पाए। So this is all for this session. If there is any questions, I will happy to take it. Otherwise, I can continue for more than 1 hour still. I have no problem.
Thank you, sir. Participants, if you have any question, you can ask. Any question? So thank you very much. I think there is no question. Thank you very much, sir.
Thank you, Vivek ji.
For
Thanks for inviting me for this session.
so participants, we will start our next session at 3 p.m. That will be delivered by Professor Vandana Dikshit from HBTU Kanpur. Okay, so you can leave now and rejoin with the same link at 3 p.m. Thank you.
Good afternoon to all the participants and organizers. At the outset, it's my privilege to be an expert speaker in 1 week faculty development program on machine learning and intelligent systems, organized by Department of Computer Science and Engineering, Rajki Engineering College, Kannauj, under AICTE Training and Learning. I feel extremely elated in extending my heartfelt thanks to the Chief Patron, Professor Vinay Kumar Pathak ji, Honorable Vice Chancellor, Dr. APJ Abdul Kalam Technical University, Lucknow, Patron of this FDP, Dr. BDK Partho ji, Director, REC Kannauj, Program Coordinator, Dr. Vivek Shrivastava, Assistant Professor, CSE Department, REC Kannauj, Convener and co-conveners of this FDP, Mr. Abhishek Bajpai, Mr. Shashank Yadav, and Mr. Naveen Tiwari, for their tireless efforts in organizing this 1 week faculty development program. So after seeking silent divine blessings from the goddess of knowledge, let me begin my talk. So just give me a couple of minutes so that I can share my screen. Is my screen visible to the participants?
Yes, madam. Yes, yes.
So the topic of my presentation is Introduction to Biometrics. In this, I will be covering majorly the face biometric work which we have done in our research times. And also I would be imposing lots of, I'll be in fact throwing to the participants lots of research problems which they can take up by using artificial intelligence. Because some of the algorithms which we have used in either in recognizing the faces and also normalizing the faces, we had done through other techniques, like through their geometric feature extractions. But the same can be done by using artificial intelligence techniques and deep learning techniques, which will be very, very beneficial, and it will be a very good research problem if you undertake. So before I begin my presentation, let me generalize what is biometric. Although all of this I will be covering in my as part of my presentation. So what do you know about biometrics? Any participant can unmute and please say if anybody knows anything about biometric.
Basically, it is used for the pattern recognition, and most of the applications are in access control system.
Ma'am, may I know your name, please?
Sujata.
Very well said. Yeah, it's used for access control majorly. I would request others to please unmute. Hello. Am I audible?
Yes, ma'am.
Okay, so biometric has the potential to make authentication dramatically faster, easier, and more secure than traditional passwords. So we all know that initially, in case you want to do authentication, so the very easy medium or mechanism was using passwords, or you want to basically secure any app or anything which you want to use, we used to use passwords. So very commonly on our mobile phones also, we generally, because nobody else should use our specific files or certain applications, so we generally add a passcode to our mobile or a password to our mobile. Then afterwards, when this smartphones had become a boom in the market and so many people had started smartphones, so in order to improve the authentication or security features, these biometric traits were inbuilt in the mobile phones. Now we all use face recognitions also on our mobile phones. We use pattern recognition, we draw patterns and then only our mobiles open. So in case of biometrics, they can increase the authentication or take it to any other level. Okay, so examples of these biometric traits are, common ones are fingerprints, facial patterns, voice, gait, iris, etc. So we'll be covering that in my slides. So biometrics provide highest level confidence in authenticating a person's identity. It has potential to dramatically improve and high-end organization security. Computers and devices can unlock automatically when they detect the fingerprint of an authenticated user. Server rooms' doors can swing open when they recognize the faces of trusted administrators, etc., and so on and so forth. So the outline of my talk will cover the basics of biometrics, certain biometrics technologies, multi-modal biometrics, certain performance metrics which are used for basically saying whether your algorithm is better. जो भी आपने biometric trait use करके अपना एक algorithm develop किया है for authentication purpose maybe, तो how good that algorithm is. So उसको उसकी benchmarking करने के लिए these certain performance metrics are there like FAR, FRR, ROC curves and equal error rates. So this we will discuss in this performance metrics and some of the applications. After we cover this, I will just show you a face recognition algorithm which we had developed in how to, what was its accuracy rates and everything. Then the basics. Why do we go in for biometric authentication? This I have discussed in brief. Then what are the frauds in industry that people went in for this biometric authentication? Because before these frauds, before in the industries, there were certain frauds which happened so frequently, then people thought of switching from traditional password kind of a system to a biometric system. Traditional password or passcode kind of a system is easy to breach and
Hello.
you can lose. Yes?
Ma'am, your presentation is not visible, I think.
Not visible.
Slides are not visible.
Achha, wait, I've shared my...
We select the presentation, but actually the PPT is not in slideshow.
Achha, it is in slideshow only. It is in slideshow mode only. Wait a minute, I'll share it again. Actually, Vivek, it is giving a message, host disabled participant screen sharing.
So, ma'am, I made you host. Now you can share.
Okay, wait a minute. Yes. Is it visible now?
Yes, now it is visible.
Yes, yes.
Participants visible.
Yes, yes, it is visible.
Yes,
Slides
ma'am,
are not
visible.
changing now. I don't know why, what happened.
Yes, sir. Visible, sir.
Wait a minute. I'll just... Wait a minute. Let me just do it again. So we were on outlines. So
Ma'am, not visible.
again, it is not visible.
Yes, ma'am.
Is it visible in this mode?
No, ma'am.
But on my screen, it is showing that, wait a minute.
Earlier, it is showing.
You are screen sharing. It has stop share again. Is it visible now?
Yes, ma'am.
Okay, I'm doing a slideshow and just let me know if it is visible or not.
Do in a read mode. Do it in a read mode, ma'am. So you can, yeah.
Is it visible now?
Yeah.
Yes, yes.
Okay. So we were on biometric authentication, then frauds in the industry. So I was explaining this key initially when we were using password kind of a system. So there were many frauds. So where these frauds occur, what is the frequency of these frauds, and why we need to switch to a biometric authentication system. Then very confused. There is a lot of confusion amongst people about what is biometric identification versus what is biometric verification. So depending upon your application, you need to design either an identification system or a verification system. So this we will we'll be discussing in detail. Now, as I said, what is a biometric? The automated use of behavioral and physiological characteristics to determine or verify an identity of a person is called a biometrics. So either initially you were using signatures. No, suppose you are going to a bank and you need to withdraw money from the bank. So your signature will be verified from the one which is saved on a system. Okay, so another option is that you can carry any card, any kind of card where your some number is there, you know, SSN number or PAN number. You show the card to the person and then he will verify your details, and then you can go inside. You know, the door will get open and you can get an access to go inside. So isme kya hota tha, in the older versions, many a times it used to happen that there was a problem of stealing of the cards, or you just a minute, give me 1 minute. Or sometimes you may lose your card, or theft might have happened. So these type of problems were there. But the advantage with the biometric system is that you do not need to carry anything with you. You yourself is a person, or you're having the trait with you which is inbuilt. It's a physiological characteristic. So this is a very advantageous thing, because the person is carrying the trait by him or herself. So as I was talking about the frauds in industry, so frauds may happen during following situations. Safety deposit boxes or vaults. Suppose you are opening your safety deposit and you are entering a PIN, and there is a person sneaking from behind and he gets to know the PIN. And then anytime he can come back and open using that particular PIN. In bank transactions like ATM withdrawals, again, somebody can steal your password, sneaking in or hacking it. Access to computers and emails, again, leakage of your particular passcode. Then credit card purchases, purchase of house, car, clothes or jewelry, getting official documents like birth certificates or passports, obtaining court papers, driving license, getting into confidential workplace, and writing checks. So while writing check also, when you are performing your signature, it can be, there are many cases, and we listen to these type of frauds almost daily maybe. So it is very important that one should go in for biometric traits in case we want more security. Now, why biometric applications? So this is what I have already discussed: to prevent stealing of possessions that mark the authorized person's identity, example, security badges, licenses, or properties. To prevent fraudulent acts like faking ID badges or licenses. To ensure safety and security, thus decrease crime rates. Now, as I was discussing, what is biometric identification versus what is biometric verification? Now, when we say that you want to go, suppose you have opened an account in a bank. Okay, so your account is already opened and you have your signatures, all your details available with the person sitting on the next counter of the bank. So what you have to do, you will just go, you will sign, they will match your signature with the one which is already stored, or maybe any kind of PIN you give to the bank people that is in the confidential or encrypted state. They will verify it, and then they will say whether you are the right person or you are the wrong person or the fake person. So what will the message which will be coming? Either authenticated yes or no. So it is called one-to-one matching. So one-to-one matching or one-to-one mapping falls in the verification category. So whenever you want to design a biometric application for securing the bank transactions, you will be designing the application under biometric verification. Similarly, suppose we go to the airport. Once you go to the airport, any person, like you are going to the migration officer, he will be taking your, all of you would have gone to the airport, he will be taking your iris pattern, then he'll be taking your fingerprint pattern, and so on and so forth. Then he or she, whosoever is the migration officer, he or she will be verifying your data with the one which he has, or the criminal data or the FBI data or whatever data. If you have any kind of history, or you are not, you are having any kind of passport problem, or your passport was detained for some reason, then he will say, sorry madam, you cannot go, please step out, let me further check. So customs officer will come and they will check all your details, and if they are satisfied, then only they will allow you to further go inside, or maybe you will be stamped the visa or whatever. So then this matching will be one against many saved in the database. So if you're designing an application for airports, for any other thing, high-end security application using biometric, it will fall in the category of biometric identification. So you can very well see that verification, designing a biometric verification application is still not that difficult as compared to designing a biometric identification application. So this is identification versus verification. Identification determines the identity of the person, whether you are right or wrong, or you are available in the database against any other thing. It determines whether the person is indeed who or he claims to be. Like बैंक में आप जा रहे हो, तो आपको पता है कि मैं वंदना दीक्षित हूँ और मुझे अपने X account से पैसे निकालने हैं. So whether the person is indeed who he or she claims to be. Next, no identity claim here. Many to one mapping. Cost of computation is proportional to number of records of users. So as I'm saying, designing an identification system will be computationally very expensive, and what it will be proportional to? The number of records of users. If your database size of criminals is trillions of records, so you can imagine how much time your system, how efficient your biometric identification system has to be to give the top 10 matches or top K matches or whatever. In case of verification, the identity claim from the user, one-to-one mapping, the cost of computation is independent of the number of records of users because it's a one-to-one mapping. So captured biometric signatures in case of identification come from a set of known biometric features stored in the system. In case of verification, captured biometric signatures may be unknown to the system. Now, some biometric technologies. There are many biometric technologies depending upon which trait you choose. Then what are the desired properties of these biometric traits and their comparisons? Types of biometric identifiers. There are two types of identifiers commonly used. Physiological. Physiological are the ones which you carry with you. Like your face can be a biometric trait. Your fingerprint which you possess can be a biometric trait. Your hand geometry and the iris patterns. Behavioral can be signature or voice. This is how you, but The problem is with both the identifiers, because physiological also change with time, because your face may not remain the same. If your face, if you are a 10-year-old, your face features will be different. If you're 40-year-old, it will be different. And when you age, you will have wrinkles on your face. So nowadays, a lot of research is going on in the age face identification. How you can foolproof your biometric system so that it can identify a person at any age. So a lot of research is going on in this area, and I mean, it is open to the participants to pick this as one of the research topics, because it is still not taken care of that efficiently. Fingerprint is the most commonly used biometric trait because of the ease of capture, because of the low cost of the sensor, because of the lots and lots of available algorithms. But here you can work on, like if I want to pose any research problem, you can work something on spooking fingerprints. Like people have these fancy ideas of, erroneously taking the print of a person, then they design that kind of a machine, that kind of a thing or a thin film which you can wear and then go and use the print. Okay, we have seen in many movies that these type of applications are used so that unauthorized people are also entering into some very secured environment. So how you can work on this? So this is another research area. Otherwise, lots and lots of work has been done in case of fingerprint trait. Hand geometry still needs to be explored because it is not that easy, because hand patterns also keeps changing over time. The hand pattern of a person, and it is not fixed also. Hand pattern of a person who's not working or using his or her hands much will be very different from the ones who are laborers and they use their hand often. Iris is a very secure trait. The results of iris as a biometric traits are very, very good. Efficiency is high, but there are issues related to iris also. We'll discuss this in later slides. Behavioral, signature and voice. Again, problem with signature is it is also very commonly used, but the problem is like sometimes the pressure of the pen may not be same as the pressure of the pen which you use often. The ink of the pen may not be same. There's so many issues, and with time your signature also changes. Like when you are young, you sign with a particular angle or particular speed. Once you age, basically the pressure which you apply or your hands get shaky. So these are the issues with this. Voice patterns, again the same issue. At younger age, your voice modulation may be different. At older age, your voice modulation may again change. So these are the problems with these type of identifiers. Then less used or emerging identifiers are physiological में DNA. Again, problem with DNA is people are not you do not get the data easily. Where will you get the DNA patterns of a person? Who's going to give you a DNA pattern? So it is very intrusive. It is called an intrusive trait. Like if somebody asks me, I will never give my DNA pattern to anybody for making a biometric application. So the problem with DNA is that, so it is still emerging. Ear shape. Ear shape is again not easy to capture and work with. Odor. Odor is a very recently added biometric trait. A lot of work is still on with odor, but yeah. Problem again is how to capture the data. Retina is very sensitive. Iris is easy to capture and there are many iris sensors available. But yes, retina is not that easy because the sensors may harm the eye veins. So people are not very conversant or they are not very user friendly in giving these type of traits. Then skin reflectance, thermogram, etc. Behavioral, which are emerging, are gait, keystroke and lip motion. Gait is how you walk. So again, making a biometric system using gait is not that easy because you need specific sensors to capture the movement of a person. Keystroke, how we press the keys, with what speed we are pressing. So there are sensors available which will capture your keystroke, but this is not very easy to capture. Pehle to capturing of data acquisition is a problem, then extracting features from that acquired data becomes a problem. And lip motion. So lip motion also varies how a person talks. Like if I'm giving a lecture, I will be speaking with some kind of, I will be stressing on so many words. But when I'm speaking to my daughter, my son, or maybe like this, I may not use the same kind of modulation or same kind of lip motion all the time. Then this is a very frequently used biometric trait, the fingerprint. Now in fingerprints, we have sensors available. What we do on the sensor, we just press our thumb. The captured thing out of it will be the minutiae points. So there are algorithms available based on minutiae points. There are lower order Delhoni triangle based fingerprint extraction you can do. And you can design your own features in case of fingerprints. So this is a very commonly used thing like arc or a loop or a whirl. So this is what we have in the fingerprints. These three categories. Either your fingerprint will be having whatever we capture through a sensor, either it will have these arcs, it may have a loop, that's a circular thing, or a whirl, round, 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 like this. So when these can become your minutiae points. Minutiae points are the ones which will become your features. So it is claimed that every individual has, when you capture many minutiae points, so it is claimed that every individual will have a different minutiae signature. Okay, so this becomes your features. So we use a sensor, we acquire the image of the fingerprint. After acquiring the image, we find the minutiae points. And once we find the minutiae points, we design our algorithms. They become our feature set. Okay, so there comes a new fingerprint. You again identify the minutiae points. Then you match from the set of the database, which you have already stored, whether this is the one, this is matching or not matching. So the next I was discussing was hand geometry. Hand geometry is captured using a CCTV camera or a LED. It's an orthographic scanning. So recognition systems crossover, we'll discuss what a crossover is around 0.1%. So it is not that frequently used trait now. Initially, people had worked in hand geometry. Next is iris. Iris is a very robust trait in case of, or a very robust identifier in case of biometric system design. And lots of research work has been done using iris as an efficient biometric trait. The only issue with iris initially was, now people do not have that reservation, but initially there was a reservation that people had this fear of giving their iris signature. People used to think that it might harm their eyes, especially in rural areas. Like we also went at one point of time to collect the iris signature from some village near Kanpur. And I think that I'm talking about way back in 2003-4 or something. And there were people who were very scared of giving their iris signature. Nahi, meri aankh kharab ho jayegi, ye kya ho raha hai, kyun kare hum, kyun de. So it was circumventive, We'll discuss all of these points later. It's intrusive. But nowadays people do not have that reservation because they feel that the sensors of iris are very safe and everybody is ready to give their iris signature now. So another issue for a research organization where you have money constraint is the sensor for acquiring the iris signature is slightly expensive. So if you have a research organization where money is not a problem, then you can opt it as a biometric trait and it's very, very efficient and you get very good FAR, FRR and all those performance metrics. Face. Now, face is a very, very commonly used biometric trait. Every one of us has, I think, one form or the other has gone through face recognition. Airports, it's very common. Face, like very common algorithm for using a face biometric was principal component analysis initially. This is a statistical method. Now, problem with face is only कौन से feature हम select करें face में जो कि unique हो. And the second problem with face is the size of the data is huge in case of faces. So if you want to design a biometric identification system, you need to be really worried about the storage space and the throughputs of the system. So you need very high-end machines because eventually if you are making an identification system, you are matching one face with say trillions of faces stored in the database. So you need to imagine, because kitne sare points ho jayenge, so you have to precisely decide your feature vector. The size of the feature vector should be small. In case of these statistical methods, they used to convert the face into eigenfaces. So what happens if you have made a database of, first you have collected the faces, then you convert them into eigenfaces. So all the faces needs to be transformed to eigenfaces. Then any particular query face comes, that is to be converted to eigenface. Then you're matching with so many eigenfaces. So the size of the data is very, very huge. And 2D face recognition, the accuracy was very less initially. Then lots of work has been done in this area. And then we had shifted to 3D face recognition. Again, in 3D face recognition, the accuracy of the system is drastically improved. Dramatically, you get very good results. So people were very happy initially. But again, the issue is, if the size of the database increases, then the points across one face itne zyada ho jate, the size of the feature vector grows dramatically, so the identification becomes very difficult. You can say that computational costs increase. Then these are the desired properties of selecting any biometric trait. If you are going in for fingerprint or face or whatever we have discussed, signature, gait, ear biometrics or whatever, every trait must have these desired properties. Iska comparison I'll be showing in the next slide. First one is universality. Every person must possess it. So everyone should have a fingerprint. What about people who do not have they have their hands or wrist chopped? People do not have their fingerprints only. And there are certain laborers who use their hands so often कि इनका ये fingerprint pattern ही घिस जाता है. So, but ये cases ये depend करता है कि आपकी application कहाँ पे oriented है and कितनी ज़्यादा universal है. It should, but हम लोग इसी assumption पे जाते हैं कि fingerprint is universal, everybody possesses it. Okay. Then uniqueness. कि one fingerprint should be different from other fingerprint. मतलब one trait, one particular feature should be different from the other feature. It should be unique. That is why it becomes a biometric trait. If it is not unique, it cannot be a biometric trait. Then permanence. Permanence is what? कि जो आपका signature या trait है, वो over the time is same. As हमने अभी discuss किया था कि if we talk of face biometric, जो आपका face features है, वो 10 year में, then 40 year में, then 80 year में, it will not be permanent. So you have to add a certain thing to your algorithm so that it can successfully detect a person at different ages. So that is called permanence. That is why we say कि हमारे passport की validity 10 साल ही क्यों होती है? Why not it is 50 years? Because your face changes. How will a person, a migration officer will identify your image at 10 years and then you are going to US maybe at 50 years of age. So permanence is a very important desired property of a good trait. Then collectability. We have discussed this also, how easily you can collect a trait. Like for example, fingerprint is very easy. Every person is ready to give a fingerprint scan. You tell me, I will go and give my scan. But if I talk of iris, I may be reluctant. I do not want to give my iris signature because these rays may harm my eye or kill my veins. I don't want to give. Like in China and all, there are certain Southeast Asian countries where they are very scared of anything touching their body parts. So this is also a problem, and this was discussed in this. People do not want to get touched by any outside scanners. So how to collect the data? How to collect the data? So DNA, nobody will give. It is very difficult to collect DNA patterns of people. So you should select a trait which is very easy for people to accept it. Acceptance should be easy. Then performance. But obvious, the performance of any biometric trait should be good. So as I have discussed, fingerprints are doing well. Faces are doing well. But there, up till now, up till recent researches, there is no single trait which gives 100% accuracy. That is why people go to multi-model biometric system. So I'll come to that. What are multi-model biometric system? Not one trait. You can fuse or merge 2 or 3 traits to give a better efficiency. Then users acceptability, I have discussed this. People are not that acceptable in giving their biometric traits to the people who are working. Then robust against circumvention. What does this mean? You should not be able to forge it. As I discussed already, fingerprints are easy to forge. There are many people sitting at your back and ready to, just capture your fingerprint. There are many people sitting at your back and forging your signatures. So your trait should be such or robust that it should be not easily forged. Then this is a comparison. When we talk of a biometric trait, like against accuracy, if you see, fingerprint has high accuracy, hand geometry has medium, voice has medium, retina is very high, iris is medium, signature is medium, but face has low accuracy. Okay, ease of use, fingerprint medium, hand geometry is high, voice high, retina low, iris medium, like this. Similarly, user acceptance, you say fingerprint ki user acceptance is low, medium, high, and so on. So when you compare these traits, how to select a trait becomes a challenge. There is not one single trait available which is having all these desired properties. Now that is why we come to multi-model biometric system, because if you want to really increase the accuracy of your biometric system, sometimes it happens that single trait may not work well. So you go in for a multi-model kind of a system where you can select 2 or 3 traits and then fuse and get a better result. So here are some examples. Face verification identification you can use with fingerprint, with signature, and with iris. So we all know Aadhaar card. Every one of us possess an Aadhaar card. In the Aadhaar card, when you go to enroll yourself or get the Aadhaar card made, they take your fingerprints also, and they are not taking one fingerprint, 4 or 5. Initially, they were all 10 fingerprints, but later on, when the Aadhaar card, this deployment evolved, they started taking 3 to 4 fingerprints only of a person, because everybody does not have all 10 fingerprints intact. If you're a very young guy and you're not working with your hands, so or you'll get all the 10 fingerprints. But if you're an older person, you may not get all 10. So आपका deployment, आपका authentication हो ही नहीं पाएगा. इसीलिए later on it was changed to some other fingerprints. So when you had gone in for enrollment, आपका iris signature भी लिया गया था, आपका fingerprint, your signature, all 3. So then it was fused. All these 3 traits were fused to get a better accuracy. Now Aadhaar is that card which is biometric enabled identification card. Okay, it is a biometric enabled authentication card. So in case of multi-model biometrics also, inputs can be like if you are fusing all these 4 traits, excuse me. The input can be face image and the output can be face, then signature, then iris and fingerprint. The output can be in case of verification, अगर हम इन 4 traits को fuse करके इनका and or whatever करके fusion technique we'll discuss later. अगर हम कोई biometric identification system बनाते हैं, so what will be the output? The best n matches. If it is a verification status, तो इसका output क्या होगा? Either accepted or rejected. A person is either accepted because it's a 1-to-1 mapping, and that is your 1-to-many mapping. Now, process for verification. Based on input and security level, arrange the traits to be considered. Using input and nature of problems, check for the match in database. Use multi-model biometric model. If not found incorrect match, add input in database for further use and assign an ID number. Okay, this is the process. First, you need to enroll. First, you need to arrange all the 4 traits. Then you have to use the biometric, multi-model biometric model. And then if the match is not found, you have to again put it as an input. And you have to assign a new ID to that particular trait. Now, process of identification. Based on input and security level, arrange the traits to be considered. Using input and nature of problems, get m possible matches from the database. Using multi-model biometric system, get only n best possible matches. In case of identification, what is our output? The top n matches or a top k matches. If it is a small database, it could be top 10 matches. In case of verification, what is our output? Either yes or no, accepted or rejected. If not found, incorrect match, add input in the database for further use and assign an ID, the same as verification. Now, what are the issues with multimodal systems? Now, this is very important. Issues are purpose of using multimodal biometrics. Like, for example, if you want to really secure your house, okay, so you attach a biometric system at the entrance. Suppose a face system or a fingerprint system or a thumb pattern. If your thumb is authenticated, you're a family member, only then you can enter. In case of such a scenario, obviously you do not expect thieves to every time entering somebody's house. So in this case, if you add 4 biometrics, it is not cost effective. Why do you at any person's house, why you need a biometric system which has 4 traits? Because the computation power you really need in this, because you're fusing 4 traits, and then you need a very high-end scanners for all of those 4 traits. You don't need such a heavy kind of a biometric system, multimodal biometric system at just entrance of the house. But yeah, if you are talking of organizations like NASA, ISRO, or maybe real-time operating system or any expert system organizations or artificial intelligence robotics organization, you really need high-end security. Okay, in that case, you decide a multimodal biometric system, because then you need accuracy to really go very, very high. Now, then what are the other issues? What are the traits to be integrated? It means like how easily you can fuse the traits. Fingerprint can be fused with face can be fused with signature. But if you talk of DNA pattern fusing with face, this will become difficult because researchers have not gone in for such a study. So, what are the traits to be integrated? Then handling large size databases, because generally in case of identification system, the database sizes are really huge. So how to handle large size databases with not 1 but 3 to 4 traits, because you need to capture all 4 traits related to all millions of files in the database. So in that case, it becomes really very cumbersome to manage all 4 traits or maybe 3 traits in case of multimodal biometric systems. Now, how to develop a multimodal biometric system? What does this mean? Scanning आप कर लोगे. Data acquisition, if you have high-end scanners, आप scanning कर लोगे. Database आपका design हो जाएगा. सब कुछ हो जाएगा. But then fusion कैसे करोगे? All 4 algorithms, how are you develop separate algorithms for each trait? Then the question is how to fuse them. So development of a multimodal biometric system in itself is very cumbersome. Then the accuracy. Accuracy is because you are designing a multimodal biometric system and you expect that the accuracy of the system should be very high. Otherwise, you can only go in for 1 trait. Why to go in for multiple traits like in Aadhaar card or whatever? Then speed of the system. This we have already discussed, because you are having a large size of the database. With each single particular data in the database, you are attaching 4 traits. Then you are doing fusion. Then you are searching. In case of identification, you're doing one-to-many map. Then the speed of the data, because you want real-time response. You cannot keep waiting at the migration officer's desk. He's matching for 10 minutes and you're just standing over there. There'll be a queue behind. So you want real-time response. So you need to design a system in such a way that the speed of the system is very high. Then, unfortunately, a single trait may not give 100% accuracy, as I have discussed, and there is a need of combining some of the traits to get the better accuracy. A multimodal biometric system uses multiple applications to capture different types of biometrics. This allows the integration of 2 or more types of biometric systems in order to meet stringent performance requirements. A multimodal system could be, for instance, a combination of fingerprint, face, voice, and smart card, or any other combination of biometrics. This is same we have in case of Aadhaar card. This enhanced structure takes advantage of the proficiency of each individual biometric and can be used to overcome some of the limitations of single biometric. For instance, it is estimated that 5% of the population does not have legible fingerprints. A voice could be altered by a cold These are the examples that why we go in for multi-model, because it is statistically said that 5% of the population does not discuss this. Laborers are there, artisans are there, craftsmen are there, and these people work with their hands so much that they do not have legible fingerprints. Voice could be altered by cold, but if the weather conditions are different, your voice generally alters, so modulation becomes different, you know, at different points of time. And face recognition systems are susceptible to changes in ambient light and the pose of the subject. Let us forget age. Like हमने सिर्फ 10 years की age के bracket में multi model biometric system भी design किया हो, तो भी आपकी प्रॉब्लम क्या होती है फेस के साथ में कि फेस का कैप्चर जो है बहुत कंट्रोल्ड एनवायरनमेंट में होना चाहिए. With the same illumination, like if you're sitting and capturing a face and the light condition is varying, like suppose right now whatever light is thrown on my face, I'll get a different picture. If I go to and stand in front of a halogen light, my face features will be very different. So illumination is a very big challenge in case of face recognition. So ambient light is a constraint in case of face. So you need to capture the face in a controlled environment. Now in case of a crime scene, how will you get a controlled environment? Crime scene can be done at night. Crime scene can be done at crime scene can occur in the afternoon also. So ambient light conditions will vary. So when you'll not get the real face features, how will you identify the criminal? So this is one challenge here. And the pose of the subject, because we are always not giving our face in the frontal way. If you give a face in the frontal way, frontal manner, the features captured will remain the same. Okay, you like your eyes, nose. Now suppose I have a habit of, you know, standing like this or like this. So in case of real time environment, in case आप face recognition system develop कर रहे हो और आपके पास में controlled environment है, तब तो ये बिल्कुल ठीक है, कोई इशू नहीं है. आप बोल दो subject को कि वो बिल्कुल सीधा बैठा रहे, so you'll get the frontal face. But in case of CCTV cameras, there will be no criminal who will be giving his footage in the camera straight away. He'll be either tilting the face or hiding the face. So pose of the subject is a challenge. So a multi-model system which combines the conclusions made by a number of unrelated biometric indicators can overcome many of these restrictions. Okay. So this is just an example that how to register, like how will you register an iris with your fingerprint, with your face and your this minutiae points. These are multiple fingers, not a single finger. It's a thermogram. Okay, this is a thermogram and this is your minutiae enrollment. Fingers in this. Hello everyone again. I guess there was some network issue. Am I audible again?
Yes, ma'am.
Okay. Screen is not visible right now.
Yes, ma'am. Screen is not visible.
Wait, I'll be sharing it. Just a moment. Is the screen visible now?
Yes, ma'am, visible.
Sorry?
Yes,
Visible, ma'am.
visible now, ma'am.
But I'm not able to change the slides. I don't know, something has gone wrong. Wait a minute. Let me just give me 1 minute more.
Visible, ma'am.
I know it is visible, but I'm not able to change the slides.
Okay.
So let me stop share and reshare it. Just a moment, please. Something has gone wrong here again. Now can the participants see my screen? Sir, is my
Ma'am?
screen visible?
My screen is showing, but slides
not
are not showing. The slides are not showing.
Okay. Just a moment, huh? I'm trying. Now is it visible?
No, ma'am.
Still the slides are not visible?
Slides are not visible, ma'am.
On my screen it is showing the slides. Screen is being shared, it is showing. They're not visible right now?
No, ma'am.
I don't know, something has gone wrong because of the network issue maybe. I'll just check my network speed, just a moment. Yeah? Sir, is it visible now?
Yes, visible now.
Thank you. Just let me come to the slide where I was. One moment. So we were discussing types of multi-biometrics. So I was saying that fusion from a single biometric trait. So you can have, instead of one finger capture, which is like very popular in most of the systems, you just give a thumb scan. But nowadays there are scanners which take 4 fingers or 3 fingers. So we all know about Aadhaar card also. They take 3, 4 fingers at a time and they fuse. There's a fusion technique to get the higher end accuracy. Then fusion of multiple algorithms from a single biometric trait. This is the second option, that you just use a thumbprint, one single thumb, left thumb or a right thumb, but you use different algorithm. One could be minutiae based algorithm, one could be lower order Delhoni triangular based. You have multiple algorithms, use the single trait and then fuse all those algorithms to get better results. Then the last one is fusion of multiple biometric traits, which is very challenging, but we have seen that it is successfully working in case of Aadhaar cards. So it is fusion of multiple biometric traits. You take iris, you take fingerprint, you take signature, and then you fuse all of them to get better accuracy. So these are the 3 types of fusions which are popularly used. Fusion, you have understood that you have a single trait, then you make a biometric algorithm for it, and then you fuse it. हम fusion किस जगह पे करते हैं? Fusion at the feature level feature extraction level means when you're extracting the features. For example, from the face, your features can be your eyebrows, your nose tip, your endpoints of your lips, your any other visible feature on the face. So this is based on face geometry. So if you are extracting these features, और हम feature level पे fusion कर सकते हैं. Second is fusion at the matching score level. Once you have found out the matching score, और वहीं पे हम तीनों, जैसे हमने fingerprint से एक matching score निकाल लिया, then after that iris से निकाल लिया, then फिर हमने चाहे उनको उस level पे fuse किया, matching square level पे, at the end level, last level, कि what accuracy you get if you fuse all 3. Then fusion at the decision level. While making the decision, you do the fusion. So multi-model biometric scheme improves the speed, improves the speed, improves the verification, identification accuracy by combining the confidence values associated with the decisions made by each individual biometrics. Now we need to define a confidence measure for each decision and a good fusion criteria. These are certain important aspects of a multi-model biometrics scheme, that you need to define a confidence measure for each decision and a good fusion criteria. Now we assume that capital I is the number of individuals in the database, M is the number of traits like fingerprint, iris, or whatever number of traits. So NIM will be what? Normalized score for the trait M of user I. It's a normalized score, means of different traits stored in the database. Now what could be your fusion method? It could be a simple sum. You sum all the NIMs, okay, with respect to each I, जो भी आपके जितने भी users हैं. Then min of the score can be one fusion method, max of the score, and then the user weighting, weighted average score. This is one example. Like we have a sensor. Now we are taking the face and the voice in this case as example. So the sensor will capture the face. So these are the sensors, like maybe from the camera. And voice, you have this mic which is capturing the voice of the same person. Then we have extractor. This is a block diagram, you can say. The first is sensors will acquire the data. So we have two traits and we have acquired the data here. Then we have extractors, feature extractor algorithms will be developing for extracting the face features and the voice features. Similarly, then we have classifiers for classifying the face and the voice. The output will be the face MLP or the voice MLP. Then finally, जो ये features मिले आपको, simple हमने ANDing की है उसकी, and then you will come to a decision whether it's a verification example, whether it is accepted or rejected. Okay. So objective is to build a hybrid and expandable biometric app prototype, potential to be a middleware and a research tool. Now we discuss quickly some of the performance metrics. There is these performance metrics will be telling whether designed biometric system जो भी आपने design किया है, how good it is. So these are the benchmarks you can say in evaluating any biometric system over the other biometric system. So one is confusion matrix, FAR is false accept rate, FRR is false reject rate, distributed analysis, threshold analysis, and ROC curve, that is receiver operating curve. So if you read any biometric research paper, eventually they will be justifying that how their system is good by using any of these performance metrics. You can generally, most of the time we see FAR and FRR and ROC curves. Okay, and threshold analysis is also one of them. So confusion matrix is basically these are your classes and these are the IDs of the, जो भी आपका data stored या features stored है, ID1, ID2 and ID3. Now over here is correct match and this is a wrong match. So this is a false accept and this is a false reject. So over this yellow thing, you decide whether this could be accepted or not. So you have to, through experimentation, you have to decide any threshold. Now in such cases, कि हम जब threshold decide करते हैं, तो generally on experimentation basis करते हैं, कि जैसे जैसे हमारा database size बढ़ता जाता है, तो we decide कि initially हमने threshold इतना रखा था, तो इतने false accept हो रहे हैं, इतने false reject हो रहे हैं, अगर उसको close करना है हमको, so then we reduce the threshold or increase the threshold. Over here, if you apply any artificial intelligence or machine learning techniques, then this threshold can be fixed by using machine learning techniques. So which becomes easier as compared to experimentation based threshold computation. So that is why in face recognition systems or any other systems, it is advisable to use, it is good nowadays to use machine learning techniques. Then these are the few definitions. What is FAR? Total false acceptance upon total false attempts. Okay. FRR is total false rejection upon total true attempts. Okay. Then EER is equal error rate, where FAR and FRR are equal. So FTE is another thing which we compute, that is false to enroll, failure to enroll, sorry. You are an authenticated person, but because you are not able to enroll yourself, that is failure to enroll. Then ability to verify is another definition. Now this is the distribution analysis. I'll skip few of these. I'll come to threshold analysis. Is we compute a graph like this. FAR, जो भी आपका आता है upon FRR, we compute this graph, and this is your equal error rate. Okay. Now we come to ROC, that is receiver operating curve. ROC curve is the graph plotted in between false accept rate and false reject rate. So this should be as close to the axis as possible. So you can say in the forensic applications generally, we get an original curve like this. Okay. So these are high security applications. But I mean, better curve would be if it comes closer to your this axis, X and the Y axis. Just give me 1 minute. Thank you. Now, in the last section of this first topic, I will be discussing about some of the biometric applications. Authentication applications, identification applications, applications by technologies, and commercial products. So these are the different places where you will be using your biometric model or biometric system which you have designed. Authentication application can be biometric enabled authentication applications. All are very popular. We all use them, like cell phones, laptops, workstations, PDAs, and handheld devices, like opening the door, car, garage access. So these are authentication. Authentication is same as verification. One-to-one match, that we know that I want to enter the door and my profile is already enrolled. It will just say the output of this will be, first it will enroll your biometric, the output will be yes or no. You're authenticated, you're not authenticated. If you're authenticated, the door will open, you can enter. If you are not, then a message will come that sorry, you are not the authenticated person. Then ATM access and smartphones. Then biometric enabled identification applications, forensic, that is criminal tracking. Examples, fingerprints or DNA matching we can use for forensic applications, because DNA matching, when we'll use, suppose somebody is dead and then you want to ensure the identity of that person. So from a dead person, you cannot get many things. So you'll be using the DNA patterns in that case. Then car park surveillance, frequent customers tracking. Commercial products, the eyes identify. These are some of the commercial products which are already deployed in the market for biometric systems. Like face, these are the ones. The voice print, all of this. Fingerprint, biomouse, finger chip, all of these. Okay. So now I will be quickly showing you what we have done in 3D face recognition. That is a part of the research work which we have done. Before I go into that, let me ask the audience if you have any doubts up till now, or any query or any question. One by one, you can unmute yourself and then we can just take up a few questions.
No, ma'am.
Okay. Shall I continue in that case?
Yes, ma'am. Yes, ma'am.
So up till now, things were translucent. You could get something. Did it make sense? I'm asking the audience, the participants. You've understood certain things?
Yes, ma'am. Yes, ma'am.
All right. So I will be continuing with this now. So the problem taken here was 3D face recognition system based on feature extraction and use of this to regenerate the face features. So both we had done. First is identifying certain features from 3D faces, and then those features were used to re-identify the face, because we are talking of a 3D face here. So the problems which I told you, कि in case of any face recognition system, the problems are related to illumination, मतलब जो आपकी ambient light है, the pose and the expression. Two were tackled initially. कि आपका illumination conditions can be handled, pose can be handled. You can still say the signature needs to be given, या face enrollment has to be done in the frontal manner, or 45-degree tilt may be allowed. But what about expression? If I am the subject and I am enrolling my face, if I'm not smiling initially, because when you talk of 3D face, हम लोग geometry, face geometry ही will be our features, like eyebrows, face के end points of the lips, nose end points, the nose tip, the nose dip, these will be your features. Okay, so if you smile, first, initially I'm not smiling. Next time when I come and enroll myself and I'm smiling. So think about it, how my features change. My endpoints of the lips will change, the nose patterns may change, and there are many things which may vary. So there's a chance of false reject in case of enrollment. So my system, what the systems we had designed were catering to all of these type of problems. So the methodology used to extract regions of interest was, पहले तो सबसे पहला important thing was how to normalize the face, because when we talk of a 3D face, we need to bring to a set frontal location so that we can extract certain features. So normalization in itself was a very challenging task. This is a pre-processing step, and most of our work in 3D face recognition, half of 50% of it was normalizing the face. And then after we normalize the face, what do you mean by normalization of the face? Bringing it to frontal position and setting the axis like X, Y, and Z axis. And then face becomes frontal. And then you extract the regions. First is you have to select the region of interest. Now region of interest in our case was, we don't need forehead because यहाँ पे there are no features. We also don't need these cheeks because more or less these are flat areas. What is a region of interest? The eyebrows, because they are slightly out. The eyes, in 3D face, you will not get the iris. You will not get the center of the eye. So what we had done, we had broken it into different regions, and then we had fitted curves, three-dimensional curves. So that we'll discuss in the later slides. Then the region segmentation. Region segment, because we need to reduce the points. So first we had selected this region, and then we had broken it into parts. Then we had extracted eyebrows, we had extracted nose, and we had extracted lips. So pre-processing was normalization. I will not discuss the entire algorithm, but I will discuss what we had done. See, I'll show you the images and explain. This is our original face, suppose. Now it is tilted towards your y-axis. We need to bring to the, first we need to convert, we need to rotate it to the y-axis, bring it frontal. It could be rotated to the x-axis also, then bring it frontal, and it could be rotated to the z-axis also with respect to z-axis. So we need to change all these orientations to bring it to a frontal face. Now once the face becomes frontal, we need to scale it to, because every different face was having different different points. These are the points of interest, and number of points were there. So we need to scale it to bring to one standard form. So first is, we had drawn this face equator line. This line was between the high, सबसे like उससे पहले हमने क्या किया था कि हमने एक 6 tuple define किया था, जिसमें कि आपके x, y, z values of each point. This is a point cloud. You can see this is a point cloud. With respect to each face, we were getting a point cloud data. Now, from a point cloud, with respect to each point, and with one face, with respect to one face, there are millions of points. So with respect to each point, we had defined the x coordinate, y, and the z coordinate, then x normal, y normal, and z normal. Okay? So this face equator line was a line between pk, xk, yk, zk, a point z coordinate, जिसमें कि z coordinate value सबसे ज़्यादा है. सारे पॉइंट्स के हमारे x, y, z हैं, जिसमें z coordinate वैल्यू सबसे ज्यादा थी. एक वो पॉइंट सेलेक्ट किया, लेट दैट पॉइंट बी pl, और फिर जिसमें कि y coordinate सबसे मिनिमम है. So there was a line drawn between these two, maximum z coordinate out of all the points and minimum y coordinate. So this line when was drawn, with respect to the y-axis, it was tilted by an angle. So tilted 3D face. These were the जब line draw की तो हमने पता किया कि there's a tilt across x-axis, there's a tilt across z-axis, and there's a tilt across y-axis. So we need to rotate all of these 3D rotations we had done to bring it to reduce all these tilts. So these were the steps used. Steps for removing the tilt along x-axis. So these were certain steps. Now steps for removing the tilt along z-axis, and then the steps for removing the tilt along the y-axis. Once this was done, all of this is the pre-processing or the normalization. Once this was done, the original face which we got like this was converted to a normalized face like this. This is complete frontal face, and this is also scaled according to our need. Now, as I said, with respect to one face only, we had lots and lots of points. So in order to reduce the computation cost of our biometric system, we had selected certain regions of interest. Okay. So algorithms for region of interest selection was divide the normalized face into uniform rectangular grids, calculate surface normals to each grid, determine the regions of interest by computing angle between normal of adjacent horizontal and adjacent vertical planes, and then segment the regions of interest, and finally extract regions like eyebrows, nose, and lips. So computation of surface normals हमने कैसे किया था? Like, see, you can see that the entire face, normalized face, was divided into number of grids. हर grid में जो horizontal और vertical, जैसे this, it's very small, although this particular grid and the next grid, दोनों के बीच में horizontal and vertical के बीच में we have made surface normals, and then with those surface normals we had computed the angle. So region, then we had done the region segmentation. So by experimentation only. Now here we had not applied any machine learning techniques. This was just based on experimentation, that for the huge size of the database which we had considered, we had by experiment found that the eyebrow region may y coordinate lies between this value and this value, whereas x coordinate is less than 0 and left eyebrow is greater than the right eyebrow. This is through experimentation. In the nose region, x coordinate lies between this value, and y. So by writing a program, we had just divided the entire face into and found this segmented region of face. Okay. Then eyebrow, we had extracted again using this algorithm. So this is how we had extracted the eyebrows. This is the extracted left eyebrow, and this is the extracted right eyebrow. Then nose extraction, we could extract the region of nose like this. Okay. Next is lips. This is the lip extraction. Then finally, we could find these control points or features. What are these? What we had done in our work, these points represent the minimum set of feature points required to define uniquely a 3D face. So in our case, there were only 12 points which were our features. Okay, with respect to one single face. Now you can imagine, out of one face which was having so many points, हमारे जो unique features with respect to one face आए were only 12. So that is why the computation cost of this particular algorithm was very less, and naturally with respect, क्योंकि computation cost was less, the response time also of the system was very fast. So these are finally which we had concluded, ये हमारे eyebrow ये points आए थे. 12 control points are extracted automatically from eyebrows, nose, and lips region. The control points are 4 endpoints of the eyebrows. This is P1, P2. These are 2 eyebrow endpoints, and P3, P4. Okay. Then endpoints of the nose, P5 and P6. This is P5 and this is P6. These are the endpoints of the nose. Nose tip, P7. This is the nose tip. This is the nose dip. Nose saddle point is P8. Then P10 and P11. So these are our control points on face. Now endpoints of left eyebrow, right eyebrow, and nose, how we have done, this is the algorithm. So I mean, not going into the details. Then nose tip and nose saddle point, how we have extracted, nose tip and lip midpoint. And finally, the face recognition, how we have done. And automatic face recognition attempts to match control points on a given 3D face with the, so हमारा जो database था, this was Binghamton University database. Now with respect to each and every face, we had found, first calculated 12 control points with respect to each face, and instead of storing the face, now we have stored the feature points in the database. Only the feature points with every face was given an ID, and with respect to that ID, 12 feature points were saved. So what we are saying is, previously stored control points of subjects in the database, these control points cannot be same for two different faces. Therefore, the matching technique which uses control points can give good accuracy. Database is prepared by first calculating the 12 control points of the subjects under various expressions. Now, I told you, यहाँ पे हम लोगों ने expression database use किया है. So we can have laughing face, non-laughing, frown face. So with respect to each face, there are different expressions. And then storing the average of each control point obtained from various expressions as well as its standard deviation. So let Pij be the jth control point and the ith of the ith subject under expression k, where I is equal to 1 to 6. 1 to 6 means it is 6 expressions. For each phase, there are 6 expressions, and j are our control points 1 to 12. The average mu ij and standard deviation omega ij of the control point for the subject I of the jth control point of for the subject I can be given by these. These are standard formulas, where Pijk is the value of jth control point under kth expression for the subject I. So matching decision, 12 control points of the subject are determined. Each control point Qj is compared with Pij for the subject. So main thing which I'm saying is, in laughing expression, the lower portion around lips may have control points at different positions for the same subject. From the average and the standard deviation for all expressions of the subjects, it is found that the contribution due to the laughing expression dominates the expressions and reduces the accuracy. What I want to point out here is, for each face, there are 6 expressions. But the contribution of expression, that is the laughing expression, is major for accuracy, because बाकी सारे frown वगैरह में यहीं पे जो variation आएगा आएगा, but frown face में, but we are not considering forehead at all. But since we are considering nose endpoints and lip endpoint and lip middle point, in case of laughing, these points will really vary. It will change. So once it will change, so laughing expression ka contribution accuracy mein of this particular model of this system was highest. If the laughing expression is put into a different bin or a new bin, and the remaining expressions are kept in other bin, then the matching based on binning improves the result substantially. So what we had done, with laughing expression हमने एक accuracy निकाली, और दूसरी accuracy 5 expressions को अलग करके एक bin में रखा, और एक laughing की accuracy को अलग रख के एक bin बना दिया. So that really improved the accuracy. Therefore 3 bins are formed, one with all expressions, one without laughing expression, and one with laughing expression. The query face is sent to appropriate bin for matching based on whether the subject has laughing expression or not. So these are the experimental results. The database, the proposed algorithm has been tested on BU 3D FE, Binghamton University 3D facial expression database, where each subject contains at least 6 different expressions, such as sad, angry, laughing, neutral, surprise, disgust, and fear. Some of the sample images from the database with different expressions are shown below in the image. Okay. Then chi-score statistics is used to find the correctness. This is a standard statistic technique, chi-score measure, जो कि हमारे extracted feature और original features के बीच का confidence value बताता है. So how good our extraction is, that we had determined by using this chi-score metrics. The results are given below. Like for left eyebrow, test cases are 228. The confidence value given by chi-square metric is 99.06. These are some of the chi-score metrics. The extracted features of a 3D normalized image are shown below. These are left, right, nose, lips, and this is the entire combined features. So these are the metrics. This is showing the results, how good our extraction is. Then these are some of the results. Same 3D, this Binghamton database is used. The result for matching without and with bidding are given in the tables below. With laughing, if we have taken 100 subjects, test images were 695 with different expressions. Equal error rate was 4.67 and accuracy was 95.33%. This can really improve if we use some newer techniques like machine learning algorithms and all. This accuracy can really go up for the same system which we had designed. Now, without laughing, the accuracy was 98.73. As I said, without laughing, obviously the accuracy will increase. Now, in case with laughing, okay, we have discussed this. Now, FAR and FRR are plotted against various threshold values lying between 1 and 3. The resultant graph is shown below. Equal error rate is 1.08 at the threshold value of 2.05. So these are the other graphs, FRR versus FAR. This is GAR versus FAR. So I think I will skip the regeneration of features because I think I'll not be able to finish it within the time. So I would like to end my talk here. I hope it had made sense to the participants. So let me stop share and just. So yeah, in case any participant has query or would like to discuss anything later on also with me related to this particular talk, is free to mail me on my mail ID bdkaushik@hptu.ac.in. And in case any queries are there, you are most welcome to. I'm ready to take the queries.
Thank you very much, ma'am. Participant, you can ask questions.
Hello. Hello.
So, okay, in that case, if you guys have no query, I was very good enough to explain you each and everything.
Hello.
Yeah.
Ma'am.
Yes.
Is there any database or online database available that provide such a facility to recognize a face and based on that we can perform any task?
No, you are saying there are online face databases available. You are asking this? Is this the question?
Yes, ma'am. Any cloud databases?
Online face databases are available nowadays. Initially, there was a challenge, but you want to go, if you can just search. There are many online databases, face databases available now, but most of them are 2D database, 2D face databases.
Okay, ma'am.
List and all, many of them are there, but 3D face databases are not frequently available. But if you write to the university who have those copyrights, they freely share the database with you. You just need to sign some kind of MOU with them, and without taking any cost, they share the databases with you.
Okay. Thank you, ma'am.
Any other question?
Hello.
Yes.
Yeah, good afternoon, ma'am.
Ma'am.
Good evening.
Yeah, I just want to ask,
Yes.
database for the multi-model that readily available, or we have to just take a different data sets?
So the multi-model databases are not available. I mean, what I had shown was the work which I had done briefly at IIT Kanpur at biometrics lab, because my supervisor, Professor Falguni Gupta, he was from IIT Kanpur, and he had taken a project from MHRD that was to design a multi-model biometric system. So we had created our own database. We had physically captured, the fingerprints from the same individual. We had to call the subjects to give their fingerprint, their iris, their signatures, and ear biometrics. And then later on, different people had started working on different traits. And that is how we had collected the database. But as of now, with the best of my knowledge, I don't know whether any specific multi-model biometric database is freely available.
No, actually,
हमारे पास database तो आधार का सबसे बड़ा है. It's like crores of people, but I don't know. You cannot share. मतलब people will not share for research work.
fine. But actually, that's the same thing will be happen in the different areas also. If you want to apply the multi-model system for the different area rather than the biometric system.
But I am sure that two traits you can get from the same university, because wherever the work is, even the IIT Kanpur database, which they had created on their own, they are ready to share for research work. Matlab, from the same people's fingerprint and iris, maybe two traits they may share with you. But yes, you need to get in touch with the people there, and then because there are copyright things and all. So if your organization is interested, if you can, get some MOU done with them, they'll be for research. Everybody is ready to share the databases. There's no problem.
Thank you, ma'am.
Okay.
Hello, ma'am.
Yeah.
Ma'am, I was like asking, you must be using GAN algorithm internally, right? For this
GAN?
face detection.
No, we were not using any algorithm for the work which we have done was purely based on geometric transformations for normalization, and we had designed our own algorithms, because for a 3D face, these type of algorithms do not work. Like statistical models, these are not only the geometric modeling only works for 3D faces. But yeah, brief work which I have done on 2D faces, I had done on PCA, that is LDN PCA, principal component analysis.
But ma'am, this GAN works on 3D data also.
But I have not worked on this.
Okay. That's fine. Thank you, ma'am.
All right. Any other question, participants? Yes, over to Vivek, sir.
Okay. So thank you, everyone. Thank you, ma'am, for giving us time.
Thank you so much, dear participants.
So
for
with this,
sorry.
Yes, ma'am.
I just wanted to thank all the participants for listening to me patiently, and thanks to the organizers once again. Thank you.
Sure, ma'am.
Thank you, ma'am.
So with this, we will end today's session. We will start tomorrow's session from 11:30 a.m. onwards with same link provided. Thank you very much.
Thank you, sir.
Thank you, sir.